Yo, what up, chat? How's it going? Sadis, Zummy, what's up, man? How's it going, guys? Eprook, Wanty, hey, Iden, Lycan, is it Zupri? I think Zupri. Hey, guys, how are you? Happy Wednesday. I hope you guys are having a good Wednesday. Yeah, today's gonna be fun. I'm trying to become more deliberate with what I stream, because I love streaming. It's one of my favorite things to do. But I also love building things, and I have a bunch of other, aspirations out there. And so I'm trying to get better at, I think one of the things that's most challenging, which is, like multitasking and like doing multiple things that are kind of like solving things for you at the same time. And yeah, Quirk is something I definitely want to keep moving, especially with traction we've gotten with it lately, and just other things that like I kind of want to just revive and get back running again. And so I want to keep working on Quirk. There's a lot of work to be done as well. The neat thing here is that we're starting a company in a lot of ways. Our company Alta 4 LLC, and we, have had some opportunity already to be structured in a way that we would work like a software company. And so there's a lot of possibility here for creating organizational changes that you kind of would at like a large company. And so a lot of the things that we're doing now, like moving our repos to GitHub, or standardizing how we do CI versus CD, or how we do our automation, or where this goes, like all of these bits and pieces are going to be a little bit more thought out and a little bit more deliberate, more than just how I originally started all of this process, which was, just kind of going at it and going YOLO. And another thing too that's really cool is again, my experience that I've got with working at Hippo has definitely allowed me to appreciate more of that process, right? Sitting down and almost more of the principle side of things rather than the the engineering, I guess, or the development, whatever word you want to use. So let's talk about that a little bit, I guess. So for starters, if you guys didn't know, we created a site called the Alta 4 Wiki. And if you go to it, this is a place where we have, I just posted that in Discord or in Slack. If you look in that link right there, you'll see a bunch of articles and things like that. So what I have come to the discovery of essentially was just that I work on a lot of different things, and it's really hard to kind of document all of these things. Like I said, we're starting from scratch in a lot of ways, but I want to be able to share that process with you. And so when we started from scratch, we kind of looked at all of our logical like parts of our, whatever we're doing. And we're like, okay, are we addressing these problems the way that we want to be? And that could be things like our networking setup. That could be things like our streaming setup. That could be things like our whatever, any kind of process that we do. And so I've been documenting it. And as a matter of fact, if you go into like technical documents, you could see a lot of the thought process that we've put around kind of starting, our own venture here, and how we're kind of building it all. And so, one of the things that I guess I kind of wanted to point it out here is like I created an article on low latency, high quality live streaming setup. Now it's a little clickbaity. I won't disagree there, but I would also challenge anybody in the sense of I'd like to know anybody else who could like. It is in fact a low latency, high quality live streaming setup. It's meant for those two purposes, is to be as low latency as humanly possible and go for the highest pass through quality as possible. And we talk about it in the article, right? It's not so much meant to be just like a clickbait link, but it's how do you actually achieve that, right? And this was something that we decided like, okay, cool. going into this new business venture, we were going to really try tackling our stream setup more appropriately. And so I've been good though, Nazi. I've been good. How's it going, Shai, by the way? What's up, Aiden? How's it going? So yeah, this is a practice that I'm doing and building more and more. If you guys didn't know, all of our automation, right? All of our automation for all of our cloud resources is mostly in Pulumi these days. Explains high quality as he buffers and disconnects. Yeah, right. Yeah, and but no, like, and it's an interest. I think it's an interesting document. I think it's one that does a good job of explaining like what our goals were. The options we've tried in the past. Being and if you guys are interested in the link, you guys are more than welcome to check it out. It's right there. Oh, wait, what? My copying from my VM has been really weird lately. I don't know why that did that. Sorry about that. The second thing is the wiki. My copying out of my VM has been weird lately. But anyways, so we like I said, we've been doing this more and more. TLDR, I've been doing automation for all of our cloud resources in Pulumi for a while now. If you guys are new here or just tuning in, I really enjoy Pulumi. I don't necessarily have a massive biasness of one thing or the other. I guess like I don't really like HCL. HCL sucks. So that's probably why I don't use Terraform as much, though Terraform has something called CDK, which is pretty cool. Allows you to use languages to like build your automation. Anyways, we've talked about how our company has standardized things like our streaming setup, and like we're trying to take practices and thought into like what we're doing here. And we're trying to do the same thing again across the board with everything. Now, when I first started this whole process, we started this with a migration to the cloud, and up until then, which was about back July, I think, May, June, July, something like that. I was flying by like, by the edge of my seat. I wasn't really planning anything. I was just being like, okay, cool. Let's do this. Let's take this. Let's go here. Let's do this, whatever. It was very much more action than anything else. So coming into the new year, we had to kind of take a step back and look and be like, okay, what do we have? And like, what can we work with and what can we not work with? And so what we had was an application that had been migrated to the cloud and was running in the cloud. It was running an unideal setup. I was using Argo at the time, which I don't have anything against Argo. It just, for what I needed, it wasn't the best solution. And I still had not solved for local development, right? As we have writing an inventory report myself to track anything. Yeah, exactly. And so when I came back and I started thinking about like, okay, what are some of the things that we want to do? I really started from the ground up, right? And so one thing to note, let's do this. Let's make our page for today. What's today's date? 16? Yeah, it's the 16th, 2022. 22. Okay. So let's talk about today's agenda a bit. Today's agenda. So the first thing, again, I wanted to kind of talk about was the reasons why we are restructuring everything at Alt F4. And one of the big reasons again is to have a purpose for have a purpose to the solutions for the problems we are trying to solve. And just to add a little bit of clarity here, instead of just picking a piece of software and using it, we want to think about the problem and find the best solution, then technology after, right? And that's something we've been definitely doing for a while. We also wanted to have more reliable systems in place for things we depend on most. And I can actually talk a bit about this in the sense of like, what have we already done? Yo, Smiley, how's it going? What we've already done, we started with the network. So we did a complete refactor, a complete network refactor where we set up entirely new gateways and switches for the data center, right? And then after we did that, we did the data center refactor. And this was essentially us saying like, okay, that's great that we can use open source software or other solutions, but like, how could we actually find a way to fully utilize the, oh gosh, I can't spell, utilize the hardware available to us in the most cloud centric way possible, or cloud. Yeah, that's probably not a good word here. Cloud feeling way possible. Or we could say on-prem, most on-prem cloud way possible. I don't know, whatever. And so this is where we decided to stop using open source technologies that didn't provide solutions as good as proprietary, right? And this was again completely deliberate. It sucked that I basically looked at the virtualization market and went, I'm one person. I want to do a lot of things. I can either build all of these things myself over a long period of time, or I can just, buy it. And so we did. We went the Vcenter approach. We said, all right, I use I use VMware for a lot of different things. You can see here's my VM that I do all of my development in. I've got a VMware workstation on all of my machines that I've standardized all of my development. So like I've used VMware a lot. I've liked them a lot. And I said, you know what? We made the decision to buy completely new hardware for our networking layer, right? And the benefits we got out of that was massive, right? We're super happy with Ubiquity. There's some interesting, and I'll say this as a networking engineer and somebody who's been in the game for a little while, 100% there's some stuff that they like sold out from the like previous Edge OS thing to like their new Ubiquity OS, whatever. I mean, they're a company, they're trying to make money. Like, they're not an open source company. We went with their mainline product line solution thingy. If we go to UI.com, we went with their mainline product line thingy here, this thing where you can like scan and burr. And you know what? It's easy to use. It's very easy to use. And it gives me everything I need. I could still do my VLANing. I could still do my more complicated routing if I want to. And it's nice, and it's something that they're maintaining. So like I said, when we looked at the benefits that we got out of that decision with our network, it was like, yeah, we have to do that with our cloud, right? Like, if I could, until I can hire somebody to be a network engineer or a cloud engineer literally in my garage, or, whenever we get big enough to where we have more servers than that, I'm that person, right? And if I can, again, throw money at the problem like we did with our networking layer, lean on things like, automation that's already been built by companies and reliable systems and things like that, then we could solve that problem super well. So we did the data center refactor. We rebuilt everything with Vcenter. And I can actually show that to you guys. So I've shown this often on stream, but here, I'll show it again. So this is our Vcenter, environment thingy. I don't know, whatever. And if I click on this here, it's hard to see. Let me go ahead and move this over here. You'll see that we have a capacity of 141.51 gigahertz available. So that's just pure processing power. That's how they look at it. They don't look at it in the sense of like cores per se. They look at, okay, what's the complete capacity of performance of a cluster? and then like we just use that instead. And then memory, we've got 319 gigs of available memory, right? And then 14.64 terabytes of highly available storage. So let's talk about that a little bit, right? The goal, if we go back to this document, this document is to find a way to fully utilize the hardware in the most on-prem cloud way possible, right? So, first checkbox, right? We're looking at resources from a cloud perspective, right? From a pool perspective, right? It's just a bunch of resources, and you can provision into that as much as you can, and we can see the overall consumption and everything like that, right? We're not looking at it like, okay, I have hypervisor 01, hypervisor 02, hypervisor 03. We're not looking at it that way at all. First problem solved, being able to look at it from a cloud perspective in the sense of like just a pool of resources that I can throw VMs at and have the problem, or have it out of the box, no problem, right? Second thing, let's talk about like, I can't compare to an Amazon data center in the sense of like storage, security, uptime, things like that, obviously. Now, we do have very big battery backups that are server grade on our servers, right? But that's still like, it's still just going to be for like 30 minutes. Like it's not very long, So we have things, like fault tolerance. Like if, for example, a specific service was to die, or server, was to die, Vsphere takes care of it entirely. It knows how to do live migrations. We're leaning on vSAN, which was another choice we decided to do, which was to say, hey, let's lean on the proprietary software of Vmware again for our storage, so that we have this super highly available and performant storage for our VMs and for everything else. So yeah, like I said, we're purposely making decisions that allow us to not have to kind of revisit those decisions later, and hopefully utilize and reap the whole benefits of solving the problem. That's really what you want to do. Is you don't want to have to solve a problem and then like go back to it later and be like, you're not really reaping the full benefits. If it just means you didn't solve the problem. That's really it. And so I want to tell you guys about a quick story that we had, I think about a month or two ago. We had just set up the Vcenter cluster, and there was a big burst in everybody wanting to play the game Ark. If you guys don't know game Ark, it's this like Ark is like a survival based game. We have a lot of people in our community who like sandbox games and stuff like that as well. And so we had a lot of people interested in playing Ark. Something we do very commonly. We'll say like, okay, cool. You guys want to play the game? No worries. We'll host the server for you, and it'll stay up all the time, and it's a community driven thing, right? Well, the Ark server was deployed to the Vcenter, our Vsphere cluster, and people were playing it, and I normally get reports pretty quickly when, we have outages or things like that or whatever. I got home one day, and I went into the garage where, again, all of our servers are, and I noticed that one of the, like, literal hypervisor hosts was completely off. It was just shut down, off, sitting there, silent. I didn't realize, for one, that I wasn't getting any alerts about that, but two, that this had happened, and I had no idea how long it was down for. So, we have a lot of sensitive services in our data center. We have things like Vault, Console. We have a bunch of databases that are running as well, too. So it's a very, like, it's very congested servers in some regards. And I was like, oh my gosh, like, is Vault up? Like, can I access my passwords? Like, what? Like, oh my gosh. So I ran inside and I checked everything. Everything's green across the board. As a matter of fact, we had people playing the game Ark all day without any hiccups. And I was like, what? I was like, what happened? But I then realized that, again, because vSphere has things like live migrations where it could easily just, once it recognized the host went down, migrate that CPU to another machine, bring it back online, and hold all of that, incoming IO. I remembered that because we utilized vSAN and had a super highly available storage, that it could do those live migrations. So it was just one of those moments where I really, as I don't know if it's like as a business owner, as whatever, but like it was, in that moment, like I bought my time back with that, because I remembered thinking about it and being like, dude, I would have sat behind that server for like at least 4 hours just debugging it, trying to figure out like what the hell happened, and then getting it back online probably. So being able to not have to worry about, and to my life stop, like anybody who works in DevOps or any kind of position like that, it's very much like your late night ambulance. Like if so, like you get a call, you have to take it. Well, I guess you don't have to, but depends on your company and how you work it. I have to take it because of the level of responsibility I have at my company. I have to take it. So avoiding those as much as humanly possible is super beneficial. So that was cool. That was super cool. One other thing that became really cool was when we made that decision of standardizing and saying like, okay, we're going to use, newer products, more managed products, things like that. We actually began the ability of integrating with those products. You know what I mean? And so, for example, remember I told you that I found myself in a circumstance where I looked back at Quirk and I went, I've got these pieces of like, it's sitting in the cloud, but it's on Kubernetes and it was deployed by Argo and da-da-da-da-da. And I kind of went, okay, well, let's restructure this. Let's figure out a way where now we have this like really good foundation at, in our own personal data center. Let's now figure out a way to make it so that we can have the exact same experience, or if not close to that exact same experience, in our local data center like we do in the cloud. And so that's where Pulumi came into play. And things like Ansible as well. But the idea was that we could use Pulumi to manage vSphere, right? There's a massive desire to want to manage all of our infrastructure as code as if possible, right? We could use Terraform. Terraform is definitely an option. And I looked at Terraform. It's not something I didn't look at. But I really do enjoy writing my IAC with logic more than HCL. I think HCL is great for very simple things. And by simple, I mean you can get to a pretty decent, well-designed infrastructure and to a pretty decent scale with it. Like it's not something you make like 2 apps and then you go like to Pulumi. That's not what I'm saying at all. But what I am saying is it's like if you have bad design or bad even just bad code practices, it can really hurt how you write your HCL. And it's the same thing with Pulumi, to be honest. But it's a little bit nicer, I think, in the regards that you have like type safety and things like that, which is really helpful, I think, for me. You can define your own schemas a bit more in your own shapes and your own opinionations. Now, again, with great power comes great responsibility. So, there is that. However, TLDR, at the end of the day, we picked Pulumi because that was just something I also wanted to try. I'd already been using Terraform for a long time. I already used Argo. I was like, all right, let's give Pulumi a shot. So we found this Vsphere Provider. If you guys don't know what what a provider is, this is the same for Terraform. It's something that allows you to interact with the services or the external services that you're trying to use. So, for example, if Amazon is the external services or are the external services you're trying to use, then you would use the Amazon provider, right? That technically means, and one of the benefits of using things like Terraform and Pulumi is that you can have multiple providers in the same automation, right? So what became valuable very quickly was, oh, snap, I can write my cloud automation right next to my on-prem automation, and they can work together if I can get it to, if I can get it to work the way I want it to. And it is actually entirely possible. And I was able to do that. I was able to, say like, oh, this is okay. Now that we've got Vcenter and Vsphere, and we have, nice. And we have the ability to, even integrate with that. One second. All right, let me get my bouncy thingy or whatever, not bouncy thingy, but the board that I stand on. It's actually kind of like a skateboard, which is pretty dope. I miss skateboarding. Anyways, so yeah, so like I said, it was just kind of like an awesome, like, if we can make this happen, then we can get some really cool benefits out of it. So what happened next? So I did that. I started writing automation for Vcenter. And out of it became some pretty cool, like cloud-centric automation that allowed me to create these VMs that we now see in here, right? So most of these VMs, all of the Kubernetes cluster, like let's take a look at what we've got provisioned here, right? So the first thing I just want to point out is the Kubernetes cluster, right? So I had talked about this desire of wanting to run a cloud, setup similar to something that I would experience with Amazon, but that I didn't mean that in the sense of like, okay, we're going to copy every single one of Amazon's features and then just like do that. No, what I meant is in the way that we work with the cloud, can we provide ourselves the same features or tools here locally like we have in the cloud? And for us, we use Kubernetes. That's the biggest thing we use. I standardized using Kubernetes because it's portable. It's something that I can then put elsewhere. And that decision made it so that we could deploy Kubernetes locally, right? So again, it's all about these decisions and making sure that they are helpful later on. If I had deployed all of Quirk to Azure container instances, right, then I would not have any way of just taking my containers and dropping them in my data center. I would have to figure out a different type of orchestrator, right? And this is the same thing with AWS ECS, right? Amazon Elastic Container Service, yes, a great service. Yes, I use it at my work. Yes, I do think it's a nice service. However, me going, okay, let's, move Quirk off of ECS to the local, data center it'd be the same thing. I'd be like, okay, well, now we got to figure out a completely different way of deploying this. And that wasn't the goal, right? That wasn't the goal. The goal was to say like, okay, we can deploy the same thing here, same thing here, same thing there. Kubernetes enabled us to do that. So that's why after we got our automation working with vSphere, the first thing we did was we created our Kubernetes cluster, right? And it's actually a pretty sizable cluster. It's got 3 system nodes and 6 worker nodes. I didn't know I had 6. 6 worker nodes. It's completely horizontally scalable as far as our data center can take it. And it's completely what's it called? Integrated with VMware as well. So one thing to quickly note about that, because some of you might say, well, okay, that's great. You got VMware for just your cloud provider stuff. Oh, no. No, I did not. And as a matter of fact, anybody who again, is looking at this is like, oh, yeah, but you used money to solve the problem. Ew. Hold on 1 second. One of the hardest things about managing Kubernetes, in my personal opinion, at least, is persistence, data persistence, right? It's just challenging. There's so many different designs and approaches to it, right? When I started looking at deploying our Kubernetes cluster to vSphere, I noticed something very interesting, which was VMware has gone as far as to create their own VMware Kubernetes cloud provider. Now, in the same way, or well, not same way, but in the similar way that Pulumi uses cloud providers to interact with, their resources and things like that. This is essentially the same thing with Kubernetes. What I was able to do, I didn't know this was possible when we did vSAN, to be honest with you. This was just one of those like, whoa, we got this win out of nowhere. If you use Vsphere, you can also use Kubernetes with your Vsphere deployment for resources like persistent volumes. That also means that if you want to, and you are using a super highly available and replicated distributed storage like vSAN, you can store all of your Kubernetes volumes on your vSAN, and that is exactly what we do. So, there's a lot of Kubernetes like volume solutions out there. There's, I think the latest one I looked at was called Longhorn. Yeah, as a matter of fact, I deployed it for a little while even and tried it out. But these are solutions that are designed to make it so that you can have highly available distributed storage in your Kubernetes clusters, but then also integrate those very easily with your services. So you're just like, okay, give me a physical volume. That's the Longhorn storage type. And then it just underlying, takes care of everything. It's very integrated into Kubernetes and stuff like that. I ran this, and it's not terrible, but this requires extra work, right? I'm not just running, vSphere in Pulumi now. I'm also running vSphere, Pulumi, and Longhorn, right? So it wasn't so much that like even Longhorn was a bad product, right? Or a bad option, right? It was more like, I don't want to have to do anything that I don't want to have to do. It's a valid argument. It's one of the reasons why I do my job daily for automating things. And so when I noticed that you could do that, I quickly figured out how to integrate this Kubernetes cluster with our vSAN or with our vSphere data center. And so when we did that enabled us to make it so that you'll see here there's a kubevals. See this right here, kubevals, this folder? This kubevals folder is actually a folder with if I open this up, every physical volume that's created in the cluster. And these are all stored on the vSAN. Again, they're replicated, highly available, all that good, all those cool buzzwords. But in all reality, it does make my persistence in my Kubernetes cluster now even more reliable and more battle ready. So that was again, really, really, really nice. So it just made sense more to kind of stay with Pulumi and go like, okay, this is something where we're getting benefits out of it. We can integrate with our existing services as well. Let's kind of keep exploring that and see where we can go with it. Thank you for the follows, by the way, guys. Let me catch up with chat here. Give me 1 second. Sorry. Because we got a lot to go through today. I see a Windows manager. I join. Oh, thanks. Aramis, how's it going? Hello. Has any Vim emulator for Notion? No, I wish, but no. I mean, to be honest with you, the Notion user interface is pretty great, in my personal opinion. Now, I mean, I like to kind of do this really weird jump between very simple and then very complex, where I'm like, yeah, I just want simple markdown, and then I'm also like, yeah, but I'd love a huge friggin' embedded chart in there too. So that's one of the reasons why I really like Notion, is I can actually do that. I can have very simple markdown, and then I can embed a whole what's it called, a whole table. I can do a whole where is it? A whole board database. I could put a whole workboard under here if I wanted to, a gallery, calendar, a bunch of other stuff. So that's one of the reasons why I really like it. I don't know if you couldn't translate any of that to NeoVim, and I wouldn't want to remove those values, right? Or that value. Are you using a System 76 desktop? No. I've been interested in trying out their systems, but no, I'm not. I'm using a custom built PC. Do you hosting Quark in the cloud at the moment, or did you move back to your own blades? We moved them back to our own blades at the moment. Yeah. So easy. We moved them back when I redid the automation for Pulumi, actually. So here's what we'll say. So the next thing we'll talk about is the automation refactor, right? And so the automation refactor was really standardize how do I want to say this? Standardize the how we do automation with particular parts of our systems, right? And that was really what the automation refactor was focused on. So for example, to standardize how we automate particular parts of our systems, instead of manually, we'll say manually, managing cloud or managing virtual machines, let's use an IAC solution that we can also use with other clouds, providers, etc. Right? And so we did that, right? We rebuilt our virtualization automation with Pulumi to integrate with Vsphere. So at this point, we were able to, again, have a complete network refactor, data center refactor, and then automation refactor that sat on top of that, right? And from that refactor, we were able to make it so that we can create VMs and have it integrate directly with Vsphere, so that we have a Kubernetes cluster that's now available to us, right? So we've talked about a pretty decent amount of the stack already. We talked about the incredibly low level where the networking allows us to easily manage network abstractions like VLANs, and subnetting, subnets, etc. And then allows us to easily integrate those networks with our data center solution. So this is one other thing I wanted to note about the networking refactor was that if we want to provision a VM on one VLAN, but another on a different, we should be able to do so easily and manage the routing between the two, which is what we can do. But to achieve this, we needed a managed solution. We needed managed switches. You can't do these with unmanaged switches, at least the VLANing part. So when we got that ability, right, we were then able to use that networking layer on top of the data center layer that we refactored. Where if you look in these, for example, you'll see that system 01 is on IP address 192.168.1.32. Right? But if I go to share assets, this is a virtual machine that's like a Samba share. This is on 192.168.3.8. And that's because the networking layers or the networking subnettings that I have in my in our network is purposefully set up to where, okay, like all of Kubernetes is on this network. All of our game servers are on these network, or is on this network. All of our share servers, which is like NFS and Samba, is on this network. And then at any moment, if I want to isolate that traffic, I can easily do it, right? I just be like, okay, no more routes to you guys. You're done. Now, right now, everything's open because it's a completely private network, and I don't really have to be too worried about it. But at the end of the day, I can if I want to. And these are the types of decisions that we made to be able to do that. Okay, cool. So And then again, the data center refactor gave us the ability to then create those VMs, integrate them or put them on those networks, do things like DHCP so that we can easily just get IP addresses for them, all that kind of stuff, and get us to a point to where we can now, again, do our automation refactor where we standardize how we do things, and then we rebuilt for starters. And like we said, like, okay, we got our hardware now. We need VMs now, right? Before doing anything, we're not gonna, no, don't go in there and just start clicking on stuff and making VMs. Don't do that, right? Do not do that. Wait and do this with automation. And that was what we did. We did that purposefully. And again, that was massively beneficial to us. And I'll explain more a little bit later. Well, I guess I can explain more now, which is when we put that in automation, this also allowed us to integrate with other third-party services and providers outside of our networks, right? And so the idea here is like Cloudflare, right? For example, is something that we could integrate with, where we could say like, okay, we want to change the DNS domain of a VM. So for example, let's give this a little bit of flavor. If we create a virtual machine that needs a public DNS address, right? We can use Pulumi automation to create the VM, right? Then the A record in Cloudflare, right? Create the VM in Vsphere and then the A record in Cloudflare. Think about that for a second, chat. Think about that. In my own, in our own data center here, the abilities that we have, I can create a VM with Pulumi, right? And then simultaneously go out to Cloudflare and be like, okay, let's route this to here. Or if I'm like, okay, I need to change this, I can easily change, like my IP address changes or something, I can easily just update it, right? All in one place. I don't have to go like, okay, what's my VM? Like, you know what I mean? It's just there. So this was another reason why we wanted to rebuild our automation. And again, Pulumi just happened to fit really well. Okay, so I think you guys have got a pretty good understanding, at least where we're at so far, right? Networking, data center, automation. We got VMs now. We've got Kubernetes now as well, right? So let's talk a little bit about it's a bit more about the automation, but we also needed to go back to here where we talk about like standardize how we do automation, right? The first thing and foremost was to structure where particular parts of automation go for different systems in the company. And so the idea here is like, where do products being built automation go, right? Where does products being built automation go? Where does company automation go, right? Because they're kind of different here. This is things like, keep the lights on or internal services for business needs, right? And then this is, and we don't have to say keep the lights on, we can just say internal services for business needs, right? And then we can also say product automation. And this is where like customer facing services, etc., whatever, right? You don't want both of these in the same place. You definitely don't want these in the same place. So that was kind of another thing we had to do is we had to figure out like, how do we structure all of this? Now I know that's a lot, especially for the fact that we are an hour in and we're just now getting to the topic that we're working on today. But this is kind of again, going to help you understand why we're doing everything that we're doing. So when we talk about like how we structure particular parts of automation, if we wanted to kind of like, foreplay is important, right? Yeah. If we kind of want to like expand on that a little bit, right? We could say, for example, it's not just internal services, but then also internal infrastructure automation itself, right? And so this would be things like, virtual machines, I don't know, other cloud resources, right? Cloud resources, etc. Right? But these are very generic, simple things, right? And then we also have internal services. Now, these would be like, Vault, right? Or GitLab, or basically, other things that you would essentially deploy internally that you would also use. And this is something to note here is that I'm not including, right, this automation, the like virtual machine and cloud resources stuff with the services, right? These are different parts of the stack. And so that was, again, that was another thing that was kind of important is like, let's make sure we're not putting everything in one place and just having one big automation and saying like, okay, this is all the automation for the company. Okay, this is all the like, no, we need to actually look at like, what do we care about, right? Like, what do we focus on quite a bit? And then how do we like separate those concerns? Where's product? Okay, so product automation, customer facing services. And just to talk about this one as well, this would also be customer facing infrastructure too, right? Well, this would actually be product infrastructure for customer facing services, right? And then it would be customer facing services essentially. And the idea here is just how we have, in the company kind of this like low level, like, okay, these are cloud resources and things like that. We'll need the same thing for the product automation, right? Like we'll need its own virtual machines and its own, cloud resources of like, buckets and stuff like that. But then in that same sense, we will also have the services themselves, things like APIs or webhooks or etc. Right? Like all of that stuff will be handled there. Whereas again, this is things like virtual machines, right? Cloud resources, etc. And so out of all of this came the automation repositories that I've actually created for us. Now I've shown you guys a few of them. I can show you the rest of them. But we talked about needing a repository or automation, company automation for internal infrastructure automation, right? Now, virtual machines, cloud resources, etc., right? I have a virtual on-prem repository that is built in Pulumi, right? And if we go to resource, look at this: compute cluster, content library, data center, data store, game server, Kubernetes cluster, network. Everything in here is the Pulumi automation. Look at this: system, create VM, right? What we're doing here is we're creating the VMs that you see right here. Kubernetes system worker, so forth. So when I sat down and I was like, okay, like how do I want to structure all of this? I was then able to take that and execute on it, knowing like, okay, this is all I really want here. And if you look at what's in here, you can kind of get a good understanding of what this repository maintains, right? Compute cluster, data center, data store, game server, Kubernetes cluster, right? And if we look at these, you'll see like VMs, right? We're not actually doing anything. We're not actually deploying anything, right? There's no services being started, nothing like that. We're simply just getting the automation out there, and the lower level resources out there so that we have everything that we need to be able to deploy those services, right? And that's that separation that I was talking about before of like, we need infrastructure automation And then we need service level automation. So we talked about the infrastructure level automation, the virtual on-premises stuff, right? The next thing we can talk about is the service level automation. Now, we just talked about the virtual machines and like the, buckets, all that kind of stuff. But then you might go, well, okay, BG, but what about like Kubernetes? Where's Kubernetes, right? You can't deploy Kubernetes with Vsphere. Well, you can, but I'm not using that approach. I'm not using Tanzu or whatever it's called. What we're doing is after we create the VMs, we set them up with a Ansible repository. Now, we're not using Pulumi here, right? We're not using Pulumi here. We're using Ansible here. The reason for that is because, one, I know that this is going to be pretty hard to maintain anyways. And two, a lot of the steps that I have to take are more like bash steps, right? Go to this machine, run this command, have it initialize itself into the node, right? These are all things that are like super common and not really something that I would automate with like a stateful system like Pulumi, but it is something I could automate with Ansible. And so that's what we did. I created an Ansible playbook that has a bunch of different roles in it that goes out to all of the machines. And as a matter of fact, if we go to inventory, you can see here system 0.1 and then system replica 0 through 3 and then worker replicas 0.1 through 0.6. So it knows how, to not only talk to every machine in the cluster, but also if I wanted to add like 10 more nodes, I could just easily change this index from 0.6 to 14 or whatever. So again, taking a step back, right? Network, create VLANs, have all that sweet network, isolation and routing and all that good stuff. Data center, to be able to then utilize that network and create sweet VMs and have them all, isolated on their own networks, but, be able to run and communicate with each other, right? Then we did our automation where we actually created those VMs, right? Got them in the cloud in our data center and running, right? And then after that, we said, okay, cool. We know that we can't necessarily manage the VMs themselves with Pulumi. So we're going to take a step away from Pulumi for a second, and we're going to manage all of that stuff the way that, the tried and true Ansible way, just doing it with some automation, good old fashioned, Ansible automation. So this gives us Kubernetes now. Now we have Kubernetes, right? So when we say, hey, I need to be able to deploy my company infrastructure automation. Every one of you should understand what I'm talking about now. I'm not going to go over it again. Well, I will if you need me to, but you should understand what I'm talking about now, right? So when I say our internal services automation, if we automated our infrastructure with Vsphere and we deployed Kubernetes for something, what do you think we're going to automate our service automation against? Right? What do you think is the next thing? Right? We used Vsphere for a specific purpose to get us those sweet VMs and those sweet networks and the sweet storage and all of those physical cloud resources, right? To get us to Kubernetes, right? So if we were using the Vsphere provider before, my question to you guys is, what provider do you think we would be using for our services? Do you think we'd be using the Vsphere provider again? Say that again. Shut up, Nazi. Or do you think we'd use something else? I'm asking, by the way. If anyone can answer. If not, it's fine. I'll answer it. Trying to catch up with chat too. Okay. So I think I'm caught up. Yeah. TLDR. We're going to be using Kubernetes automation now. And the thing to note here, the time I didn't hear, wish I could answer. No, it's okay. It's okay. I was just basically asking what provider we would be using next, right? If we used Vsphere, the idea and like the mentality I'm trying to give you guys is what are we using to get the wins that we want, right? We're using our data center refactor and chose, let's say, chose Vsphere to provide the most, we'll say, compatible functionality with our hardware and support for the most or the closest, we'll say closest possible on-prem cloud solution. No, I'm not going to be using Argo, not anymore at least. And again, so like I was trying to say is we use vSphere to get all of the virtual machines, again, cloud resources and stuff like that. We're going to use, and we're going to standardize and say all of our services go in Kubernetes, right? If all of our cloud automation goes in vSphere, then all of our service automation needs to go into Kubernetes. Now, Kubernetes itself is a very interesting beast because you can use it multiple ways. You can use it to deploy services. You can deploy it as an IaaS or IA infrastructure. SaaS, SaaS. You can use it for running internal services. You can use it for a janitorial cron system. Like there's so many different ways that you can use Kubernetes. Now the ways I use Kubernetes is very similar to the ways that I use my cloud providers, right? Where I have these two same layers again of having that like lower level infrastructure automation. Now these aren't virtual machines per se, but they're like lower level requirements that the Kubernetes cluster needs, right? We're talking about things like ingress controller, like how do you route requests to your service, right? We're talking about volume classes or storage classes. How do you save your data in your Kubernetes cluster, and things like that. Now we already solved for the volume problem because we integrated our Kubernetes cluster directly into vSphere, so that's not a problem. But things like ingress, other things, like we haven't solved all of the problems yet. So when we talk about product infrastructure, this isn't really virtual machines or just virtual machines. This is also Kubernetes resources. And these are things like ingress controller, etc., right? Now, with this repository, right, it was the virtual, what was it? Virtual on-prem, I think it was what it's called. Yeah, virtual on-prem repository. This, we actually ended up calling our cluster on-prem repository. Cluster on-prem. Now, what you might notice is this on-prem standardization where I'm using and saying like, okay, this is for our on-premises automation. But then I'm saying like, okay, it's the virtual automation or it's the cluster automation. In this sense, I'm using the term cluster as Kubernetes cluster. So I could have made this like Kubernetes on-prem if I wanted to or something like that. And I might change it. Cluster's kind of a little too vague here, but I did this a while ago and I haven't updated it yet since. But I showed you in the virtual on-prem automation in Pulumi how we create the virtual machines and manage them and all of that stuff, right? Well, when that automation runs, it never touches any other automation, right? It doesn't touch the Kubernetes automation. It doesn't touch anything else, right? So there's two parts to that. One, if I delete something in the virtual on-prem, so say for example, if I just blow away the whole cluster, well, my automation that runs against that cluster is also not going to work. That's true. That's entirely true. That was going to happen no matter what, though. If the cluster goes away, yeah, your automation's not going to work. So the benefit of separating them like this is making it so that if I want to make low-level changes, I don't have to affect the other layers of my stack, right? This goes way back to the first part of the conversation that I said, where we wanted to standardize how we do automation in particular parts of our system. What we're basically saying is, hey, for this particular concern, right? Virtual machines, all that stuff, you go here and you do this, okay? And for this stuff over here in Kubernetes world, you do this. You don't touch this over here. They are separate. Keep them separate. But you can go touch this and then do what you need to. So we're continuing that pattern as we walk into the Kubernetes world. Now, if we were just deploying services, then we really wouldn't need this cluster on-prem repository, right, or automation. This is the automation that we need as a company to do the things that we want to do, and we want to deploy those things in Kubernetes. And so, for example, if you were to say like, okay, well, what do those services mean? If we are, for example, if we're building an Azure DevOps, I want an agent in our Kubernetes cluster, right, so that I can run CI pipelines. We used to run Bitwarden. We don't run Bitwarden anymore locally. We use their cloud solution now, but we used to run Bitwarden here on site. We don't do that anymore. Cloudflare. Remember how I told you guys that we made it so that we can integrate directly with Cloudflare. This is a Cloudflare tunnel called Cloudflare D. And this allows me to make it so that you guys can access the wiki. So when you go to Alt F4 wiki, you're going to Cloudflare, which then has a tunnel that is this tunnel right here. As a matter of fact, see this? Discourse public URL, discourse URL, right? So this is the internal service URL that we're routing to. And then this is the public URL that you guys get to go through. But all of this is automated, right? All of this is a part of that. This is all scoped again. And I like I said, I wouldn't want to say like, if I needed to update Quirk, I wouldn't want to run automation or vice versa. That could potentially change this. So this automation, again, just solves the company problem of like cluster services that we need to be able to do the things that we want to do. Samba, Plex, Knative, right? GitLab, Console, Vault, Valero, TwinGate, our VPN services, right? All that's in there. Now, like I said, you guys know we work on Quirk. Do you see Quirk anywhere here? No, of course not. You totally don't. Like we're solving it layer by layer, right? We automated the virtual machines and created them. We then used Ansible to put Kubernetes on top of those virtual machines. Now we've created Pulumi automation. We've created Pulumi automation to create the next layer of resources that we need, which sit directly on top of Kubernetes. So once this automation runs, we get things like, what can I show you? I'm trying to think of one I can actually show you because most of these are like internal and private. I can show you Vault. I mean, I'm not gonna like show you secrets or anything, but like here you go. So see this vault.alt-f4 domains. This is Kubernetes ran and hosted. And as a matter of fact, if we go here, right, go out of here, K9s, Vault, there you are. There's our 3 replicas, the agent injector. This is that Kubernetes cluster right there. So remember, what did we automate? We automated the virtual machines. We automated the provisioning of Kubernetes on top of it. We automated the provisioning of the low-level resources that are in that Kubernetes cluster, right? We have all the cool toys that we wanted now, right? That's kind of the thing I ran into is like, I have all these cool toys that I want to deploy to Kubernetes so that I can use Kubernetes more, right? But I don't want those cool toys to be with, my services and products that I'm deploying, right? I don't want it to be with Quirk. I want Quirk to just expect those things to be there. Kind of like a cloud provider works, right? This is our cloud provider. Yeah, it's going to be private. This is all, yeah. So these repos are private because they're all internal. I'm showing you guys these. They're in the future. These could be public. The main reason for that is because one little thing about Pulumi that's awesome is that, like, you guys want to see my production secrets? Bam, there they are. Hack me, bro. No, they're encrypted by default. Pulumi uses a encryption at rest approach to where all these values are read at runtime and then decrypted via like my credentials and stuff, right? And I could make it public. I don't know yet, man. This is like, dude, look at this. Like, this is my vault configuration. Like, it's not too, and again, it's not even really too terrible. There's nothing in here that I would be worried about sharing. But again, it's something I'm thinking about. Don't worry about it. It's definitely something I'm thinking about. I want to share with you guys. But I do try and be as detailed as I can in these. No way 2 of those were encrypted. Yeah, not all of them are. Not all of them are. One of them's not. Choosingly, right? That one's not. Bare metal. And this one. Yeah. If you want to know the name of our storage or our resource group, you can. No, there are unencrypted ones in here, but they're not valuable. Didn't even see that. Whoops. Yeah, no, it's okay. I'm just showing you how you could potentially dox me. But yeah, no, like I said, these are repositories I would like to share with you guys at some point. I hope that you can understand why I'm like not just throwing them out there just yet. But yeah, like I said, this automation runs. Now we've got network, data center, virtual machines, Kubernetes, and our toys, right? All of our toys. So then we're going to talk about our service deployments, and now we're going to actually talk about the library stuff and everything else that we basically were getting into working in today. It only took me an hour to go through all of that. That's not bad. It's a lot for an hour. I think you guys got your heads wrapped around most of that. All right, so it's very hard to believe that all of us have to do this much duplicate work just to get table stakes. We need to fix that. Yeah. Meanwhile, systemd services go brrr. Yeah. I will almost always prefer. By the way, how's it going, Proportionate? How are you? I will always almost prefer something like Pulumi over Terraform. Hell no, with DSL over HCL. I mean, again, I have no desire in this channel to do any type of like this is better than that, whatever nonsense. It's whatever you want to use. I've used HCL enough to where I just found where the annoyances in the language are. Do anything with a for loop, and then try changing that value later on and see how it works. There's ways of getting around it too. They've hacked on the language, and they've made it a little bit better. But like, just you give me my own language, then it's like, oh, not my own language. You know what I mean? One I'm used to. It's like, bam, like I got it, no problem. Now, again, here's something I really want to point out, and it's funny because like Jordan, one of our friends, he reached out to me because they're building Blip, their site thing, or not their site thing, geez, their content creator platform thing, and he was like, well, what would you suggest? Like, would you use Pulumi or Terraform? And I was like, listen, I really like Pulumi, but I don't know how great it will be for everyone if you don't know how to just write good automation logic for one, and two, abstractions. I've seen myself, even like when I first wrote things in like AWS CDK and things like that, like it became this nightmare of like having to pass values around and like not leaning on really good even like code practices of like using classes and inheritance. Like you have to think about those things, right? You have to think about like how you're, it's a lot more reuse logic than just like writing logic that works for you, right? You almost every piece of logic you use, you're probably going to reuse. That's really how it's supposed to work. So it can be very challenging if you don't know how to write that logic in a normal language, right? HCL gives you like the bouncy bars or whatever they're called, the safety bars in the bowling alley to like make sure you don't like hit a gutter ball. And I do believe that firmly that HCL does that for you. But you can completely shoot yourself in the foot if you don't know how to write good automation in like JavaScript or TypeScript, or I would recommend a language that has types, so TypeScript at least. Go is a good one too. You can write all of your automation in Go. Let me catch up with chat here though. Sorry. What is the best practice about database? Self-managed database in OS or database using database container? Oh man, you're asking the real. I had conversations about this at like a Docker conference like 6 years ago. I don't care. So the reason why I answer that way is because like there are so many people who find one way of solving a problem and then just go like, this is the way, right? But like not in a cool Mandalorian way, but more so just like in a really annoying, like I've never grown out of my technical like expertise, and so I'm just going to do it this way because it does work, and I can argue and say it does work even though it doesn't really work that great. I've done both in here or on-prem, right? We're just going to call, the data center on-prem, whatever. It's all in Kubernetes. Now I did that purposely because in that same sense, I have it on super highly available persistent volumes that should never die. Right? I'm not worried about that. I solved that problem on a completely different scale, right? I solved it by saying like, well, the volume should never go down, right? So if you're to say like, well, what happens if your container crashes? It's fine. The volume gets reattached somewhere else and then it starts, right? Now, does that necessarily mean that it's easier or worse than, a cloud-based solution? No, not at all, because like managed solutions are super nice. That's why they're managed. That's why you pay the extra money to have really nice dashboards, little buttons that go click and make you restart things. But you pay for that. That's what you pay for, right? I have no need for any of that. You've seen like how I manage things. 90% of my stuff is in automation. The idea of me saying like, yeah, I'm going to go into the managed dashboards of Kubernetes or of Amazon and like, restart my RDS instance, that's more annoying than it is for me to be able to just hop into K9s really quickly right here and just be like Postgres, you can see here, we've got like 4 Postgres databases running right now, all on different nodes. Oh, well, I guess no, 2 of them are, no, they're on the same, 2 of them are on the same nodes. That's interesting. 5 and 2. Why are they both on, but they're completely different server? Interesting. I don't know, whatever. Anyways, but yeah, again, you can see here, I'm running multiple services, but I also have physical volumes for them, right? I have PVCs, right? Postgres, see? They're all on vSAN backed, highly available storage. Now somebody is going to hear everything I just said and still go, no. That's fine. Like whatever. DR, right? Okay. Disaster recovery. I use a tool called Valero. Valero is a really awesome tool that's built to have scheduled backups that are essentially complete volume snapshots. And what this allows me to do is take a whole backup of a whole namespace. I'm talking all of the Kubernetes manifests, all of the literal resources that get created with that, all of the data, all of it. Like Valero is super nice, right? And it updates the whole persisted volume to the cloud I could have it do it every 5 minutes if I wanted to. Wouldn't matter, right? And then I just use Valero again to restore it. It's got a restoration feature as well, right? Even telling people that, they would still go, no. So it's up to you, man. I solved it in a way that like, what happens when something dies? Store it with Valero. How often do I know, how often of data do I have? Back it up every hour, every 5 hours, every 6 hours, or store it with Valero, right? I don't know. It wasn't that big of a deal to me. But I will say, having your database just sitting somewhere that's really nice, that you can just like plug into and use, that's massively valuable as well. And for companies, it's probably the smartest decision. Because that's where you save money, is where by making it so engineers have more time to do the things they need to. You don't need your engineers to manage your databases. I'm doing it so that I can save money, right? Like I'm doing it because I'm a small company that can save money. And that's another thing that I need to like TLDR to every single one of you in this stream right now. All of my perspectives are from a small company. Now I work at a massive company. I work at I think we're $100 million company. I don't know. It might even be a multi-billion-dollar company. I don't know, whatever. But anyways, I work at a very large company where, if I went up to my boss and I was like, hey man, I found this way for us to save like $100 a month, but we got to manage it ourselves manually. He would be like, no. That's a waste of our time. No, that's not what we want, right? So again, I'm solving it from a very small company problem because that's how I need money. Right now I need money, chat. I need money. Subscribe. Give me your money, chat. Donate. Please help me. No, I'm just kidding. I don't mean that at all. But what I do mean is the company, right, is a completely different entity. It's its own little baby. You know, it's trying to grow. So it needs money. It needs to grow. And we are saving where we can. I can do it in a way that I trust. So yeah, that's the long spiel on that. I hate talking about that stuff, but it's just like, I've had so many detailed conversations about it. It's like, whoa. Magically disappearing, man. Yo, what's up, Indifferent? Thank you for the 18 months, buddy. Appreciate you. Use as many managed services as possible. Yeah, I mean, if you can afford it, I do think that, you know, using managed services are great. But again, it's a totally up to you. That's all I'm going to say. Do you have a write-up about your experiences with running a Rust server? I'd be interested in seeing some usage numbers. Alcaeus, I'm sorry. I'm still like catching up with chat here. I hope you're here, bud. Are you still here? I think you're here. I don't know. If you're still here, I hope you are. We have numbers. The TLDR on running a Rust server, and by Rust, I mean the game Rust, not a Rust server. This is the game Rust. It's a CPU hog, man. It takes a lot of the CPUs. Yeah, it's because of the generation and everything that it does. It takes a lot of CPUs. So that would be my one thing to note. And RAM. The startup needs like 6 gigs of RAM, and then it like flushes it all and it goes down to like 2 for the rest of the time. You literally only need RAM for the startup. That's it. You can just Google search Kubernetes CSI drivers. Yes, you can. Yes, you can. Yeah. I see the power supply heating and causing the microphone to clip isn't an issue anymore. I see the power supply. No, I don't think so. I hope not. Well, we completely restructured our stream setup. I wrote an article on it actually on our wiki, where we completely redid like the wiring, how everything is routed. Let me see if I can find it. Here you go. Yeah. So this is the article right here if you're curious. And for anyone else who's curious on how we do our streaming, that article is exactly how. Have you checked NetApp Astra? I have not. I don't know what that is. Can you give me a link? Yo, what's up, Raven? How's it going? Notion UI kind of drives me batty because I can't find stuff. Yeah, you got to get used to the quick links and knowing like where everything is in the pop-up like menu, the little like slash thing, right? As a project, Vim knows where I started, but it's in an early stage. Oh, cool. I will take a look at that. I like seeing projects that people work on. What is the Alt F4? I don't know. Try it. See what happens. You run in Calico CNI. No. We're using something called Cilium pods. Yeah, Cilium. Cilium. I got this as a suggestion from a... Oh, that was weird. What the fuck? Suggestive. Yeah, this is what we're running right now. Noatsi. I'll share it with you guys in chat. So if you guys know about like networking CSIs in Kubernetes, I like to try a bunch of different ones. I love networking. It's something that's a passion of mine. I had a friend who recommended this one. I've tried other ones before, right? Like very simple ones, like the Calico one. That's very common. I thought I'd try this one instead. So yeah. Do you use Notion just on the desktop? I started using it for some trackings, but I really don't like the mobile experience. Do you use any alternatives? I do use it everywhere. And easy when I don't. I don't really think I use it on the mobile at all, to be honest with you. I just don't really use it on mobile. Yeah, easy. I don't use it on mobile. This is a local network only. I assume you have port forwarding set up. So Aramis, we do, but we are also a company with a business line. So we do have provisionable IP addresses as well. So if I wanted to, I could expose another public IP address. We have like 6 of them or 7 of them. But yeah, we do have port forwarding. Yeah. That's all handled with the gateways that we bought, or the gateway that we bought. I've been reading up on the CNI issues PR on GitHub. Definitely a good idea to visit the GitHub for your CNI. Yes. Yeah. No, that's another reason why I tried the Cilium one as well, because it looked pretty supported, had really good, commit frequencies and stuff like that. Now to set up direct connect between your local network and AWS at some point. I'm way behind on chat, by the way, so you're going to have to give me a second because I'm catching up with all of you guys. Ever looked at AWX project? No, I have not. Can you share me a link on that one? Oh, AWX. Yeah, I said, oh, never mind. You're talking. Never mind. I just mean, oh. Yeah, if you could, I'd be interested in seeing the AWX thing. I don't know what that is. DevOps gang. What's up, the Glacian? How's it doing, buddy? The possibilities with the technologies and abstractions available to us are endless. Yeah, pretty much. I mean, especially with Kubernetes. You can do a lot with Kubernetes, man. Want to play a simple website? Build your own data center first. Yeah. I mean, hey, you'll learn how to be... Let me put it to you this way. If you want to deploy your own website and you build a data center before you do that, you'll definitely know how to do DevOps by the time you get there. I don't suggest that, by the way. My bad. I already read that. No way. Encrypted. I will almost preserve. Just use Kubernetes and you'll never have to use either. Yeah. Well, I mean, you can use Terraform with Kubernetes. You can write. I don't know why you would. You can write HCL Terraform. And what's funny is you can write HCL Terraform that literally just looks like YAML, because the HCL Terraform, or the HCL, let's say Terraform Kubernetes, if you go and look at the Kubernetes provider for Terraform, it's just the specs from Kubernetes wrapped in HCL. That's it. Like if you go to core secret, for example, right? Like look, resource, metadata, name, and like it's still gonna be the same thing, you know what I mean? Like it's so it's just like, do you want to be writing your YAML in HCL or do you want to be writing it in YAML? I don't know. How do you personally do things like port forwarding? Do you have to mess with the router settings for it? I looked into a Raspberry Pi and couldn't figure out. Well, we have a like company, like, I don't know if it's like technically enterprise, it's like business oriented, I guess. But the router gateway that we have is it's this one right here, the Unify Dream Machine Pro, this guy. And so I just go into the user interface and expose it the way I need to, you know. There are so many different ways of doing port forwarding depending on how you have your network set up. You could do it with a Raspberry Pi if you wanted in Linux firewall rules. You could go into your current gateway and figure out how to do it in there, like, you know, Linksys or whatever, ASUS, you know, settings. It's a bunch of different ways. The main point though is you have to do it where the internet like is. You have to do it at the connection of the internet. Hold up a second. Assuming a working vSphere, how much time would you guess it took to bring all of this up? Bring up all of this in a DR scenario? Yo, Raymond, thank you for the 4 months, buddy. Appreciate you. Sorry, you're gonna have to give me a second too. I'm like super delayed with chat right now. Assuming a working vSphere, which it is, how much time would you assume it would? So, what's actually pretty cool is vSphere itself does not take very long to set up, because what you really do is install vSphere or EXSI onto little thumb drives, and then you plug those into the machines and they boot off of that. So that's something to note, is you don't, with EXSI, you don't like install, you install it, but you install it onto the thumb drive. So that it gives complete control over the whole host, right? Think about that. If the if the whole operating system and everything is on this little thumb drive, right, and it can boot it into memory, then you have the ability to, bootstrap that super quickly. And that is how it works. Essentially, everything for EXSI is on a thumb drive, and you just unplug it and then plug it back in. It's very simple to create the hypervisors. Now configuring, I mean, that takes more time, but Carlos, I'll say this, man. If your DR question is like, what happens if, a few hosts, even if everything goes down, it's just going to come back up, right? Like it's, one of the nodes is going to, come back up, and then they'll start synchronizing with each other and then bringing everything back online. In the circumstance of like, it's like, just, I don't know, just like explodes, catches on fire or something like that. Then at that point, it's just from scratch, and I could probably do it in a day. It'd probably take me about a day to rebuild everything, get everything redeployed. But because there's so much automation, the steps are very simple. The things that I would have to be more concerned about are just the things I didn't automate, So probably about a day. Kubernetes is modules, Pulumi, Terraform, full circle on that one, yeah. Database container can be okay. 200 databases, some routers do, yes. I don't know what the standards. Okay, so now I think how do you test this many levels of automation? Do you have a test environment for all of this, or do you just never make mistakes? I mean, duh. I make so many mistakes. No, I don't know. I normally have a local Kubernetes development that I set up, or normally I do this stuff in a way that I can do it before I actually make the decision, right? So in the sense of like, using Vsphere, right? I just started working with integrating with it and made sure that I wasn't like affecting anything that was going to be detrimental, and if you like separate your stack that way, you can kind of get away with that pretty effectively, right? I can work with all my virtual machines and not worry about other things because they're just running in other isolated components and other parts of the system. So it's really just comes down to your isolation, I guess, of your systems. Like, if you have good isolation, then you're only going to affect a small component. You know what I mean? You have a NAS box, right? I do, but it's really old. It's not good. I don't use it. I actually had to create a whole new... If we go back into here really quickly, you'll see that I have an NFS node for Kubernetes. And that's because I needed more network distributed storage. You can't do many... Oh, wait, you guys saw that. Yeah. You guys know why we did this. If you don't know why we did this, go to the wiki, go to Twitch streams, and watch the released... Yeah. If you guys want to know why I had to deploy an NFS server the day we tried deploying the wiki, just check out that page right there. You'll see why. So yeah, like I do, but it's just not very performant. It's not very powerful. The number of folks I've had talk about using non-Valero backups is kind of nuts. Valero's de facto tool for backups. Yeah, it is. Are you contracting? No, not at the moment. I wish I was, but I can't afford that. We're doing everything. There are some projects that we can. I will say that there are some projects that come up where I can. So, feel free to join the Discord, and I would normally, that would be something I would reach out to you directly about, or somebody directly about, or I'd reach out to the community directly about. It's not something that you guys would have to feel like you have to come directly to me about it. But yeah, I would eventually reach out to the community and see if anyone wanted to help. What's up, Nix? How's it going, buddy? Any update on the on coming YouTube educational videos? Yeah, I mean, we've got 3 out right now from Microsoft. So if you go to !YT, there's a playlist on there which is encompassing all of the Microsoft series. Those are out now. You can check that out and see the whole migration to the cloud, all of that stuff. And then I am working on a video right now that shows you guys how to do some of the automation that I've done for like my development setup and stuff. And so that will be out probably next week. It's been tough to edit it. It's the challenge is it's a very nope, I'm gonna be real, nobody else could have made this video but me. Because it's very in depth, it's very detailed, it's very like specific to how I do things as well. But it's also just, it's a really good video. So I'm spending a little bit more time on it to make sure that, you guys get something really good out of it. Because it is going to be longer. I was going to try and make it short, like a 10-minute video, and then it became like a 30-minute video, and I was like, oh, geez. Okay, never mind. PG, I've been living in your world for the past few weeks, writing Terraform configs, and it's tough. Yeah, it's fun though. It's fun too though. When you get to see it all running, it's awesome. Deploy Hubble on top of that. That thing is amazing. I do have Hubble. Yeah, I do have Hubble. Yeah, it's super nice. Yeah. I use Notion on an iPad. Been watching on Twitch right now. Oh, I do use it on my iPad. That's true. I don't really consider an iPad as like a mobile thing. It's friggin' huge. I don't know. That's just me though. Chat, I can't read the messages he's at. Yeah, you weren't here. I'm almost up to date now. I thought we didn't like Kubernetes because of the magic. What? What do you mean? What magic? I don't think Kubernetes is magic. Personally. Crap, did you just show how you did it? Did what? Cloudflare tunnels? Yo, what's up, Worker? How's it going, buddy? Hey, Eric, meta question. Do you work on a 1080p screen or to not have the partial i3 workspace? Yes, I do. Yeah. Yeah, when you stream, you have to essentially work on the exact same resolution that you are sharing or that you're recording with. So to avoid it, everything's on 1080p. Yo, Indifferent. Dude, Indifferent, thank you so much for the 5 gifted subbies, man. You didn't have to do that. By the way, Nix, Opti, Pitbull, Legendary Marvin, Jordan. What's up, Jordan? All of you wonderful people. Actually, quite a few of the homies got that one. Marvin, Opti, Nix, Pitbull. Nice. Be sure to thank your gifter. Thank you so much for that, Indifferent. You didn't have to do that. Just your continued support, man. You've been heavily supportive of our stream. Thank you, man. Just store everything on Airweave. Why don't you do HDFS? What? Oh, I was like, what? I bet Rockstar could have made that video. He could have made something. Sure. I'm just kidding. I love Rocks. Vajayjay wasn't subbed. Rude. That's fine. I don't care. It's kind of hard to stay, like, when you have a lot of friends on the Twitch world, it's kind of hard to stay, like, sub to all of them. So I understand. We do the same thing, actually. It's very common. All right, guys. So tell you what, here's what's going to happen. We have talked a bit now. Well, not a bit. We've talked a lot about where we are, right? We talked about wanting to start from scratch after the beginning of the year. We have a company now. We want to create good foundations for us. How do we create those good foundations, right? So we started with our network refactor, did all of the stuff, got all the benefits out of that. We then did our data center refactor, where we gained the benefit of complete utilization, not only of our networking, but now of our hardware, so that we can create things in the cloud and do all of these other kind of cool things, right? And then after that, we said, okay, how do we manage these things effectively and appropriately, right? And so we talked about our automation refactor, where we started, looking about how we manage particular parts of automation, where these different things go, what repositories we put them in, what kind of resources are in those repositories, right? All of that kind of stuff. And then I showed you those repositories, especially with our virtualization automation, so that we could create virtual machines, integrate with other third-party services and providers as well through Pulumi and all of that kind of stuff. Now, before I take my quick little break here for a moment, which I will be doing, the pitch here, essentially, to what we're going to be doing next is, we've only talked about things that really only exist once, right? We're not going to have, well, we could, but ideally, we're not going to be creating like another environment of Vault or creating another. Most of the things that we have provisioned up until this point is so low level that it's the things that really do the isolating, right? We isolate our data in buckets. We isolate our processes in virtual machines or Kubernetes, containers and stuff, right? But now what we kind of want to talk about is okay, well, what about the scenario where we have products that we're trying to build, right? We want this, this beautiful data center that we have, right? With all of this technology and power, we want to utilize it as much as humanly possible. And even though it is in one space, right? It's just 6 servers. Think about all of the layers and abstractions and like process we've put around. Like there's a whole universe in that thing. You know what I mean? We've got virtual machines that do things, and we've got Kubernetes that does things, and then we've got services that do things, right? So there's a lot of different layers to it. The layer that we're now talking about is the layer that are things that we build go, right? So we've talked about things that other people have built and how they're going to help us. We've talked about things that we built ourselves in the sense of like, resources. But now we're talking about the actual like DevOps, like engineering development side of it, where does our code go? Where does our code go? Right? And in that, it's a bit of a different problem to solve, because now what we're talking about is like having multiple environments with the same resources, and how do we share those resources between the automation, right? Like right now, I really wouldn't have anything that I would share between, the virtualization automation and the Kubernetes automation. There's no real, there's nothing there I would really share, right? But in the sense of like Quirk, right? For example, I have an API service that I want to deploy to a dev environment and a test environment and use it locally and all these other things. But like, I want to make sure that the resources that are provisioned go with it too, right? I don't want to have to say like, okay, in the cloud, we use Pulumi and Kubernetes to deploy it, and then locally we use, Docker Compose and like all this. Like, I don't want that. I want everything to be standardized, and even so that we could share those things, right? So the idea is that what we're going to do is we're going to take a service like the API service, we're going to take it out of its current singular automation repository, and we're going to turn that into a reusable component that I can use in any automation repository. And the idea there is that these are components that could exist in multiple places. They could be components that I have in this automation library and this automation library, or maybe this one and this one, right? But we want to keep the standardization of what is created with that automation and things like that. And that's what comes into what is today. Thank you, Nyan Sloth, for putting in today, which is we are talking about, I guess that doesn't work in dark mode, but we are talking about creating an IAC. I can't highlight that. We're talking about creating an IAC library. And I do actually want to watch this video on here and see a little bit about what Pulumi says about it. But the whole idea here is that instead of us copying the API automation code and putting it here and then putting it there and so forth and so on, we create good modules that do one thing as simply as possible, meaning like, okay, it's either going to create the API service or it's going to create a specific type of service or something, right? And then have very well-defined definitions on like the options for that interface, so that when we provide the module and that specific like function, right, we can just simply configure it and get the expected deployment out of it, right? And it could be configured for local, it could be configured for, production, it could be configured for whatever. But the idea here is that we want to see how well we can package our existing services and put them elsewhere. So that's what we're going to be working on next. Like I said, I'm going to take a quick break right now. I've been going for a solid, almost 2 hours. Actually, not, man, we are killing it today, chat. Holy smokes. We're doing a lot more than I thought. So yeah, I'm going to take a quick break because we're almost at the 2 hour period. When I come back, we will start by looking at our service automation, right? We've talked about our cluster automation, getting all of those things like, the low level services like GitLab, Now we're going to talk about how we deploy our actual code that we want everything to be, this sits on top of everything, right? Like, this is what all of this is for, right? I want to be able to use Vault to integrate with my secrets, and I want to be able to use Kubernetes to run my containers, and I want to be able to use Vault, right? Like, all of the stuff we have built has been for a dependency of the next step. And this step is really the final step, which is we get to build what we want to build, and now we need to figure out how we're going to deploy that. So, like I said, I'm going to take a quick break. If you are new to our channel, hey, thank you so much for being here. I appreciate it, you wonderful soul. Be sure to check out that little blurb right there. We're basically a variety channel. It's hosted by me, Black Glasses, BG, as well as my wonderful co-host and my best friend. I was going to say, there's a great Jay and Silent Bob quote that is my heterosexual life partner. We've been best friends for a very long time, and we started this stream 3 years ago together. He plays video games and does a bunch of other cool content like builds, custom builds and things like that for like models and stuff. And then I code, I program, I work on DevOps, all that other stuff. And then we also do content together. Where we will play video games together or do IRL content, stuff like that. So it's really a place where he and I kind of hang out with you guys, hang out with the community, have fun, work on the stuff that interests us. And yeah, so thank you for being here. I appreciate that. If you also would like to, you're more than welcome to check out our wonderful Discord. That's where we live in the off hours. If you have any questions, anything like that, just want to be a part of the conversations, you're more than welcome to. That's also probably the number one place where you'll get any notification about anything we're doing. So if you ever want to know when we post something, anything like that, it's really all in the Discord. And then yeah, our social medias. Like I said, I'm not ending the stream. I'm just giving you guys a moment to look at all of that other great content. Oh, wait, sorry. Also the wiki. My bad. You guys will love the wiki. But yeah, I'm going to take my quick break. Thank you guys again for hanging out. I will be right back. So enjoy the tunes. And thank you. Your knowledge about DevOps is unparalleled, especially on Twitch. Thanks, man. I mean, I appreciate that. I hope so. I hope it helps. I really do. Let's keep doing it. So yeah, I'll be back in a second. Be right back. I'm gonna run an ad as well. If you guys don't know why I run ads during breaks, there's why. But I'll be right back. 1 second. Right back. Thanks, bud. I appreciate it. I'm actually just using my co-host's camera. All right, chat. I want to watch this video. So here's what we're gonna do. We're gonna watch this video first, and then we're going to do some work. I want to see what they have to say about this. Now, if you guys think that you need me to turn down the music, oh, thought something happened at work. If you want me to turn the music off, I can, but I think it should be fine. So let's see what this says. Now remember, we're watching a video by the Pulumi company. So this isn't like sponsored or anything. It's just, I'm just putting that out there. This is a video they made on how to create module libraries, essentially.
We've all had the experience. You're writing some code or scripting a process, and you realize you've done this before, probably more than once. At that point, hopefully your desire is to go and create something to stop you having to do it again.
Oh God,
writing some snippets or a module that you can share with your team. Well, in the infrastructure code
okay?
world, it's not
By
really
the way, guys, does that sound okay? Sound good? Do you need me to stop the music or anything? Sound good? Okay, cool.
that much difference. There's only so many ways you can deploy a virtual machine. And so ideally, if you're going to be doing a process more than once, if you're going to be deploying a resource more than once, you'll reuse rather than repeating the code. And that's what we're going to talk about today. We're going to talk about how you can use infrastructure as code tools to build a library of modules and reusable resources that hopefully will help you not repeat yourself, but also hopefully help others in your team and your company to get the benefits of your knowledge.
So again, he's talking about reusing code, infrastructure automation in multiple places, right? So that's the problem we're trying to solve here.
Code. And I'm quite lazy.
I appreciate that.
Writing the same code over and over. you want to save yourself into creating reusable modules using infrastructure as code and why you might want to do that. But the first and perhaps most obvious reason, you want to save yourself time. You want to stop repeating yourself. You want to stop writing the same code over and over again. And so you create a reusable copy of your code, and you've only got to write that once and hopefully amend some parameters or so on when you use it. And that's quite often the driving reason why somebody might want to start creating reusable infrastructure as code modules, particularly if you're working by yourself. But another benefit of this is the fact that you're going to promote consistency. If you were writing the same code over and over again, you're probably not actually writing the same code. It's going to be slightly different. And so you may find that you're deploying resources slightly differently. Maybe you've got some configuration settings that are different when you on the first time you did it to the second. Maybe they don't make that much of an impact, but they're different. And over time, as you write it again and again, those things are going to change. If you use the same code, literally the same code, over and over again, you're going to get the same output. That's going to make your resources a lot more consistent, hopefully prevent you making errors or doing things like leaving some security settings that you really want to be enabled off because you forgot to write about them at this particular time. So hopefully you'll get a lot more consistent and maybe even more secure resources when you deploy them using a reusable module. A lot of the time, you're going to find, though, that you're not working on your own, and there's other team members who are also working on the same infrastructure you're working with. And so by creating reusable modules, you can help these people as well. Firstly, you can help make things a lot less complex. Let's say you've got a way you want to deploy a virtual network, and you want everybody to use the same approach. And there's lots of different settings that need to be set up to make it the right approach. You need to set up certain network security groups. You need to set up certain root tables, all those sort of things.
You said root
Getting
tables.
everybody who's doing that to follow that approach is going to be really hard. And everyone's going to do things slightly differently, probably miss some things. And if they're new to the use of infrastructure as code, it might even make the job very daunting and difficult for them to get started with. So if we create some modules that can do that for them and make those modules so that they hide a lot of the complexity, it makes it a lot easier for people to get started with using the infrastructure as code and following your process. And it makes sure they're actually following what you want them to do every time. So you can use these modules to take a very complex set of infrastructure you want to deploy and hide it behind a much simpler interface that everyone can use. And alongside that, you can then use it to apply standards. And these just might be the way you like things done, but they might also actually be standards you've got from a corporate level or from a regulatory approach or to meet some sort of compliance, that you have to have resources deployed in a certain way. Again, if you don't have any reusable modules, then you're relying on people actually applying all those settings every time when they write their infrastructure as code. Whereas if you create a module that's got all of those standards baked in.
So one of the things that kind of sits out with me already about this is I'm wondering how
but secondly, it ensures that
services play into this
deployed and they're deployed in exactly the way you want with the appropriate settings that meet the standards you need.
Like secrets and stuff like that that are unique.
People, it's quite likely you've got your own area of expertise. Maybe you're the networking person or the web app person. But whatever it is, you can bake your expertise into a module and then let everybody else use that. So if they're not familiar with networking, they just need a virtual network to deploy their application into, and you can give them a module.
That's one of the things that we
got all your
do at
expertise
Hippo,
baked
actually.
in, and they can just run that, and they get a
really, for example, Avi will go in and create a module or something
that they can then use,
and then we'll reuse it in other places.
So it's much easier for you to share your expertise rather than having to try and go and train that person up to understand what you're doing in that code, or at the very least write the documentation that they have to follow when they want to deploy a virtual network. If you can just give them a module and say run that, and you'll get all the infrastructure.
That's literally what we do at Hippo. Orca can attest to that.
So we know why we want to create these reusable modules, but how do we actually go about doing it? And this is where it becomes much more dependent on the tooling you've chosen to write your infrastructure as code.
No, I was just saying that generally we have our abstractions in a way that Avi will make something and then we just go use it and we can just use it.
They will have their own way of doing it as well, but I've tried to call out some of the most common.
How is this? I'm going to pause really quickly. How is this different from something like Ansible? So Ansible is focused on configuration management in the sense of I want to configure this server to be like this, or I want, you know, this file to be copied here. It's more focused on like making sure processes are done before you move forward, right? Pulumi and Terraform are more about what is the current state of my infrastructure and like keeping that state essentially. And so the whole idea behind that is like not so much of did we do something, but like is this deployed? Is it configured like the way that it's supposed to be? And normally the configuration that we're talking about for like this kind of automation isn't necessarily the same with regards to like you know, like things that you would do with Ansible. Like earlier I told you guys that I use Ansible to deploy Kubernetes to my virtual machines with, right? Well, that is all, you know, that's all just like something I run and everything runs at once and then it like stops. Yeah, exactly. Something like pipelines. Yeah, exactly. What's up, Bash? How's it going? Whatever you can do, it always comes back to something you can do with Ansible. Yeah, I mean, yeah, you can, and that is something really like something to note is you could do anything with Ansible. Like at the bare minimum, Ansible is something that allows you to just like run shell scripts, and you could do that. Like you could do anything with those. You know what I mean? So you can do anything with Ansible, but again, the focus is on like what you maintain, why you maintain it, and like what you're trying to do with Ansible is very different. Thank you for the shout out, by the way. Okay, keep going.
So if we start from the top here, if you're doing deployments into Microsoft Azure and you're using the native infrastructure as code tooling there, then you've got either Azure Resource Manager or ARM templates. And these use a feature called nested templates as their sort of modularization approach, where you can write your infrastructure in one file and call it from another. Now that works, but to be honest, at this point, I wouldn't recommend going down the ARM template and nested template approach because they can get very complicated. Instead, I'd look at the second option here, which is the newer language for Azure, which is Bicep. And this has a built-in module approach that allows you to create specific modules and use them in your code.
Oh, thank you for the
If you're doing AWS and you're using the native CloudFormation language for that, then this has a concept of modules.
Yep.
And you can use those to create reusable chunks of code and then deliver them to your users. If you're using Pulumi, then these use the concept of component resources and also packages, which is a newer feature which allows you to create reusable component resources that can be used from any language. And if you're using Terraform, then this has the concept of modules as well. Right. So whichever of those languages.
Does that make sense to everybody? He's basically just comparing the different approaches to how we reuse things, right? So, for example, in Terraform, there are Terraform modules, right? You make a module, you import the module, whether if it's in a directory in another folder or you know, something completely in another cloud solution. CloudFormation, same thing. They're node modules if you're using TypeScript, Python modules if you're using Python, so forth and so on. Bicep, same thing. ARM templates was for Azure originally, but the only thing to note about all of these is just that these are things that allow you to reuse things, right? You could reuse cloud automation and stuff like that, you know, with all of these, but they do not work together per se in the sense of like, these are things you use together. They are all comparisons.
I want to dive deeper into how to do it in
I didn't either.
Go have a look at that specific.
That's the first time I've ever seen Bicep.
Documentation. So let's go and take a quick look at what a module might look like. So here in Visual Studio Code, we've got an example of a module. This one's been created using Bicep just because it's fairly easy to read.
I got to pause this really quickly. I don't mind that he's using VS Code. That's totally fine. I don't care about that at all. What I will say is my man's using light mode. Oh, it's so bright. Oh, come on, bro. I love you, but like, come on.
Sample, but obviously language.
I did not know
what we've got is a
we were going to see all of these demos in light mode.
A storage account. Now, I guess the first question you might ask is why put this in a module? Because the storage account is a fairly simple resource on its own anyway. What we're using this here for is to apply some standards and some, I guess, specific ways we want storage accounts created. So the first thing we'll do when we create a module is sort of create an interface that we want the user who's going to use it to pass in data and the data they're going to get out the other side. So here at the top, we've got the parameter settings for our module, which are the interface. And so we're asking the user to pass in a prefix, which is going to be used as part of our naming. We're going to ask them to pass in a specific SKU of what type of storage account they want and a location they want that in. And you'll notice on the
So before he goes any further, does everyone understand what these are? Right. So this is a bicep file. I don't know what that is. I've never used bicep before. But this is a file that is implementing what a cloud or what a resource component would look like in bicep, or something that is isolated and allows you to give it parameters, and then it will create whatever is in that component for you, right? And so in this case, he's saying that we have a storage module.bicep, which is for storage, I guess, in general. It's just general storage, right? And this module takes 3 parameters. Storage prefix at the top, which has a min length of 3 and a max of 11, right? Storage SKU, which allows you to give it only 4 specific parameters, the default being standard, right? And then a location of a string that you must give it. So that's just something I want to make sure you guys are all understanding here, is that this is only just an example of what it might look like to have a module in a automation system. This isn't, this is bicep. This isn't like Terraform or anything else. So yeah.
Storage SKU setting there, we've got a list of allowed types. So this is our first sort of standard approach. We're saying these are the allowed types that you're allowed to create. In particular here, this is an Azure module. You're only allowed to create standard storage accounts and not premium storage accounts. So we're saying we don't want the users using those more expensive accounts. When they use our module, they're only allowed to use these standard accounts. Then we get into the actual code for the resource, and it's fairly straightforward, but you'll note we've got that variable there, which is creating a name. And so again, we're applying another standard, and this one is a naming convention. So we want to name all our resources in a certain way. And so we're taking that prefix they passed in and then appending a unique string generator.
So one thing I want to note about this, you can care about naming resources up until a certain point when it comes to managing cloud resources. And I know you might be like, wait, what? But what I'm talking about is the actual names that get created in like your cloud provider, right? The names of those actual resources, right? We have discovered at Hippo that we've gotten to such a scale that we're just having collision issues, and like we've just the possibility of names that we can use for something has become so limited that using naming as a convention has become challenging. So definitely focus, I guess, on naming conventions on where they're important for you. There's tons of low-level things that automate a lot of these names for you out the gate. Auto naming is so, yeah, exactly. Like Pulumi does really good auto naming. Terraform doesn't do bad auto naming either in some regards. So yeah, that's just one thing to note. Like, yes, this is like good opinionation in some regards, but it's more of just to show you how you can do opinionation more so than like saying you should standardize all of your names. Okay. I'm going to step away for a second. You guys keep watching.
That will give us a sort of set naming convention for this resource. Then in the resource itself, we're using those values to actually create it. And then you'll note on line 24 there, we are setting HTTP traffic to on. So a user who's using this module cannot turn off HTTPS traffic, which is a good thing from a security perspective. But again, we're setting our standard. And then we've got the output at the end, which is the other side of the interface, where we pass this to the user of the module. When it's run and it's completed, they will get the name of the actual storage endpoint, the URL for the storage account, out the other end, which they can then pass into other resources they're going to deploy or get at the command line and use it manually. So we know why we want to create modules. We know how to create modules, but how do you create good modules? So firstly, you want your module to do one thing and do it as simple as possible. It can be quite tempting to go and build really big and complex modules that do lots of different things and are really fancy. But I've found the best approach is to make sure your module is focused in what it wants to do. So maybe it's deploying a storage account like we saw with all the standards on it. Or maybe it is doing something more complicated. Maybe you're deploying a whole Kubernetes cluster, but you're sticking to the Kubernetes cluster and you're not then reaching out to build the firewall that also is used by that Kubernetes cluster and so on. So keep them as simple as possible. You want to provide options to your users. You want to provide them parameters and ways to customize the module, but don't give them too many options. If you try and replicate every single property that you can configure inside your module on the outside, yes, it's going to make it very flexible, but it's going to make it really confusing for a user, particularly somebody who's new to using your modules or even new to infrastructure as code as a concept. You want to try and drive the user down the particular approach you want to give, but give them enough options to be able to customize it the way they want and not have to go and not use your module and write the code themselves.
That's one of the hardest things, by the way. What he's talking about right there is one of the hardest things to deal with, which is like, where do I choose to do my abstraction? Because there's many times where you'll write something and you'll be like, okay, I can reuse this everywhere. And then you go to reuse it later and then you go like, it doesn't fit the requirements I need. Awesome. And then you have to go back and refactor it to then make it fit the requirements you need. And you go, okay, now it works. Awesome. And then you leave and then you come back and say, okay, I need this. And then you go, it doesn't fit the requirements I need again. And so you got to do the whole process. And that's like, listen, if none of you have experienced that, I would be very surprised. I've experienced that a lot. It's a hard thing to avoid. How do you know that you are providing, good options that are also going to be easy for you to, maintain later on, and not just be like, because here's the thing, right? And this is one of the reasons why I'm genuinely slightly nervous about doing this still, is the approach more than likely will be to use node modules if I'm using TypeScript, which I am, which means that I will be publishing node module packages every time I need to make a change and then have that go downstream, which means more automation that I have to create and have in place for all of that to work, to where I'm not just like going into my library and publishing the package every time. Like that sucks. Like I actually hate maintaining node modules. I for any of you people who do, I salute you, because maintaining node modules packages is a nightmare. It's terrifying. It's like the Wild West. And it's very unforgiving. There's not much room for error. You basically, you do it right or you redo it again with a new version. Yeah, NPM is just not that great. It's just really not. So, he even said something that was kind of interesting to me, which I find, Orca, wouldn't you find this hilarious? I could use another language to build these higher level components in this module, so that it's an easier packaging system I can lean on as well. So that is true, right? Like, the nice thing about, yeah, exactly. Like, the nice thing about Pulumi is I'm not just restricted to JavaScript. So if I was to say like, okay, I'm not really concerned about, managing it on the automation side, right? Because I'm not managing the actual, I'm not managing it as a package. I'm just writing the automation in, TypeScript. But then to say like, okay, now I have to manage this as a package. Let's put all of that code in a different language, because Pulumi knows how to do interoperability in the sense that I can write it in any language. And then exactly. Here you go. This, what Orca just linked right here. This, write once, use in all languages. Yeah. So this could be something else that could be nice, where we say like, okay, we're going to use, not NPM, because we're going to use like Go, right? Or maybe even .NET, who knows? Yeah, that would wouldn't that be fun, dude? For me to have all of our like higher level components in .NET and then reuse them in TypeScript. I mean, it would kind of work, right? It would. I mean, they're both Microsoft, so there's that. But yeah, that's that's basically the goal here. All right, so let's go back to our where did it think? Okay, let's go back to our conversation.
Run it that
way. It would
then.
be very type safe.
To find the balance there. Your module needs to add value. There is really no point in taking a native resource and wrapping a module around it where you don't do anything else. If you're not using it to either make something simpler, to apply a standard, or to deploy multiple resources or so on, if you're just wrapping the native provider in your module and adding no value, there's no point to your module. Modules are software packages.
Keeping it real.
And so you need to make sure you're versioning them appropriately for your end users. If
See?
it's just you
So
using it,
this
then
right
maybe that's
here,
not quite so.
boop, boop. This right here, chat. Boop, boop. Really big error or really big warning right here, right? Version appropriately and NPM do not mix.
So important, but if you have other team members, you need to make sure that you're giving it a version numbering approach, that you update the version when you release a new version, and that maybe you're following something like Semver or similar, so that people know when there's a break and change, and so on. The next point's a really important one. Is you need to make your
I'm talking more
modules
about
easy to
NPM
obtain.
more than
If people
like
can't get hold of them and it's a
actual
real
versioning.
pain, then they're not going to use them. You need to make the friction to using the modules very simple.
having to do it with
And so you
NPM.
need to use the tools that are available, and we'll talk about that on the next slide, to distribute those modules to your end user so they can get them really easily. And alongside that, keep them updated. No one's going to use your modules if they're all 4 versions out of date. They don't use the latest features, and people can't deploy the latest resources with them. So make sure you keep them updated. Automate some of the processes if you need to, but make sure they're up to date. When you're building a module, start simple and then evolve it and get more complex over time. Trying to do everything at once in a big bang can be quite difficult, especially if you're new to writing them or you're working with a new resource that you're not sure how to deploy. So start with the basics, the stuff you really need in the module, and then you can add to it over time, like any good software project. Create documentation and make sure it's good and available. People are going to want to know how to use your modules. And if it's not self-explanatory from the code, or it's packaged in something like NuGet and you can't really see the code, then people aren't going to use it unless there's good documentation on how to use it. And it may be you want to look at some sort of automation to automate document creation. Things like Docx and so on can be used to create automated API docs, but make sure there are docs and make sure they're easy for people to find. And then finally, if you want people to use your modules, then you need to make sure that they know they exist, what benefits they're going to give them, and so work with people to help them get onboarded and use your modules. Again, not so required if it's just for you, but I can pretty much guarantee if you work in a company, if you start writing modules and they're useful, people are going to want to use them.
And yeah, he's 100%
to make sure
right
people
on
know
this.
about them, engage with them, and get feedback, and maybe they'll even help you build the next version, and maybe even start contributing to your library, which is another great point.
That was my Slack.
If you can make your library of modules open source, but inner source within your company, and you can get collaboration between lots of different people, you'll find that the library will grow much quicker, and you'll get people a lot more engaged with building and maintaining.
I got you guys, don't worry.
So I mentioned on the last
I used to not say something and then I would forget. Like I'd get Discord messages and people would be like, "Where is this Discord message coming from?" I was like, "Oh, my bad." Yeah, no. I have my work Slack open. Sorry, I have to. What did he say? What was his suggestion for documentation?
And you can get collaboration between lots of different people. You'll find that the library will grow much quicker, and you'll get people a lot more engaged with building and maintaining these things.
I don't know.
So I mentioned also within your company, if you can build the next version, and maybe even start contributing to your library, which is another great point, and get feedback, and maybe they'll even help you build. And can pretty much guarantee if you work, you need to make sure that they know they exist, what benefits they're going to give them, and then finally, if you want people to use your modules, then you need to make sure that they know they exist, what benefits they're going to give, and so on. The next point's a really important one. Is you need to make your modules easy to obtain. If people can't get hold of them and it's a real pain,
I don't know, dude. I'm sorry, I lost it. Just check
if you can make your library of modules open source, but inner source within your company. And
let's move back up to here.
Your modules and making them easy to get hold of is really important. So I just want to mention quickly the different strategies you've got for doing that. Again, this is more technology dependent, depending on what type of language you're using. So with both ARM templates and now Bicep.
Here, let me give you the link. You guys the link so you have it. There you go. Sorry, just want to make sure you had it.
On the Azure side, you can use this concept called template specs, which allows you to basically create a library of reusable code that you can then distribute to end users via the Azure portal. So that's one way of doing it. Or if you need to keep them sort of more closed source and within your company, you can put them into storage accounts and have people access those modules there, or even things like GitHub and so on. You can also use that as a storage place to get your modules, as long as it's accessible over HTTP. For CloudFormation, this comes with the CloudFormation registry that you can use to store your modules and distribute them to users.
So both Oak Muffin, how's it going?
With Pulumi, because
No
you're
worries.
writing actual code there, you're writing C# or Node or Python, you can use the native delivery mechanisms there like NuGet, npm, PyPy, all those sort of things. And then with Terraform, you've got a couple of options. You can actually just use Git and reference modules directly in Git. Or if you've got Terraform Enterprise, you can use the Terraform registry as well.
I thought Pulumi supported Go too.
Approach. So all of these provide you with a way of distributing modules to end users, so that the friction of getting on board and getting started is much lower.
Maybe they don't suggest.
So lastly, I just want to go over some real world use cases that I've worked on or I've used that provide really good examples of modules that are useful.
Okay.
So starting off, something like a virtual machine. So the virtual machine is a good example of reducing complexity and applying standards. When you deploy a virtual machine in whatever cloud, it's very rare that it's just a virtual machine. It usually has some network pieces with it, maybe some storage. It's going to have a lot of configuration settings around security and monitoring and those sort of things. Maybe it's going to have some extensions to install other software and so on. You're probably going to have a standard way that you...
I'm not sure, but I only ask just because Go... It can be challenging from a versioning perspective because Go mod doesn't really have versioning. So I could see why he didn't include it. Does that make sense? For anybody who uses Go, you probably understand what I'm saying a bit more. Like, it might be hard to do this with Go.
You want VMs to be deployed, but also the code to deploy a VM can be pretty big. And so creating a module that deploys a VM in a standard way that everyone can reuse is going to save people a lot of time, and it's going to make sure that they follow the standards, or you're not going to have virtual machines configured.
You can absolutely distribute it with Go modules. Are you talking about Go? I mean, so you can with Go mod, but like, you have to manage Go versioning with using Git tag. Yeah, that's what I thought. I thought it was Git tag. So, yeah. That might actually be the easiest, bro. And or broette. That's interesting, because if you think about it, if we're following Git tag revisions, we're now talking about GitOps, right? Which means we're following a very similar pattern to how we push code. Go might not be a bad play, because then it's just like merge, right? It checks for the latest. Yeah, buzzword alert. But does that make sense? Like, think about that, guys, right? Like, I don't want to have to manage NPM package. Like, I don't have to manage, yeah, I am standing, Shrek, yes. I've been standing for like 2 hours, actually. Somebody put it on and then like never redeemed it back. You bastards. No, I'm just kidding. But yeah, that is interesting, because if you could essentially just track main, right? Oh, Palm Base, thank you. I mean, it's okay. It's good exercise for me, like standing, but thank you. Hey, thank you, chat. Thank you for letting me sit. Oh. At least I know I can do that for the next like 30 minutes or so, since it's on cooldown. All right, anyways, let's keep going through this.
Figured with, the RDP port exposed to the internet or so on. So that's a really good sort of example and quite a good starting point for building a module. Another one that comes up a lot is Kubernetes clusters. And this is all really about reducing complexity. If you're going to deploy Kubernetes into one of the cloud providers, you're probably going to use their native cloud solutions, so AKS, EKS, the Google Kubernetes engine, those sort of things. But often you're not just deploying Kubernetes, you're deploying all the prerequisites that you need, so some networking, some storage, the Kubernetes cluster, but also you're going to deploy some things on top of the Kubernetes cluster. Maybe you want to run an ingress controller. Maybe you need Cert Manager running. You can deploy lots of things after you've created the Kubernetes cluster as well. And so again, that can be a really complicated set of resources. And so bundling that into a module for anyone who wants to create a Kubernetes cluster, particularly if people are spinning up Kubernetes clusters when they want to do testing and then tearing them down again. You can hide an awful lot of complexity within that module and give somebody a really simple way to deploy that. Particularly for people who aren't familiar with how to deploy and manage Kubernetes, they just want to run an application. This can be a really useful use case. Another great example is maybe you're on the networking team and you're not working with the other teams to deploy their applications or anything, but you want to make sure everybody's deploying their network following the standards. Maybe you've got a sort of a hub and spoke network and you've deployed the hub and you need to make sure everybody joins their spokes appropriately. Build a network module that you can then distribute to the various teams, and that will show them how to connect to the hub without you having to explain it and document it and so on. You just give them this network module and everything is configured correctly, follows standards, and is joined appropriately. Another one here is configuration module. And this might seem a bit odd, but it's a really useful tooling to have. So this is a module that doesn't actually create any resources, but what it has is configuration settings in it that you're going to use for other resources. It's really common within companies to have a lot of different configuration options that are unique to your company. So things like maybe external IP addresses, naming conventions, those sort of things where people need to remember to make sure they use those within their resources. So why not build a module that has all of those pre-configured so people can use that module, they can update it. So if you add more external IPs, they can just take the latest version of the module and they've got the latest IPs, and then they use those in the rest of their resources, maybe even feeding them into other modules, but it gives you a central place to store your configuration. And so that's a brief introduction on why you might want to have a look at building a library of modules and how you can go about get started. I hope you found that useful, and I hope that will encourage you to reuse rather than repeat.
Nice. I thought he was going to show me a little bit more code, but that's okay. Yo, what's up, Bald Bearded Builder? How's it going, buddy? Thank you so much for the raid. It's been a minute. Welcome back. Welcome back to Twitch. Hope you've been well, my friend. Hopefully things have been better. I know you went through some troubles a little while ago, and we were definitely sending our love to you, my dude. But I hope you guys are doing well. Hope the stream was good. Hope everything else is doing good. How are you? What were you working on? Get the music going back here. Cool. So everybody just tuning in, thank you so much for being here. I am BG. I am one of the co-hosts of the Alt F4 stream. We are a variety channel hosted by me, BG, as well as my good friend Atoda. I basically program, and Atoda plays video games, and we do IRL content and a bunch of other cool stuff together. Today, I am working on a project that we have been building for quite some time now called Quirk. Quirk is basically a streamer tools platform. It's kind of like a Stream Elements competitor, where we build a lot of things that streamers might need. Bot services, notification services, moderation tools, things like that are all things that we kind of build into our systems. Today, I'm working on the DevOps side of this, where we're talking about doing infrastructure as code libraries. And the idea here is that if I have resources that I am reusing in multiple places, right, there are some low-level standard configurations and settings there that I can reuse and re-implement. And because I'm using something called Pulumi, which allows me to use languages to write my automation, things like TypeScript or Go or Python, whatever. We can also utilize with that language the ability of sharing that code just like we could with any other code in that written language. And so that's what we're looking at today. We're going to be taking a look at the stack, looking at it from a low-level perspective and trying to understand what can we abstract, what can we put into this library so that it makes us easier to create these services in multiple places and have high reusability and all that stuff. So yeah, welcome. Thank you again for the wonderful raid. My dude, appreciate you. Again, I hope you guys had a wonderful stream. For you. There we go. And there's a shout out for you. If you guys don't know a Bald Bearded Builder, you definitely should. We've known them for a while, actually, before the stream was called Bald Bearded Builder. But yeah. Are you switching from Terraform to Pulumi? No, not entirely. No, just for some of the stuff that I'm using. There was someone from Pulumi team who showed some real code and DevOps directive channel on YouTube. Oh, okay, cool. Pulumi is written using Golang, so it would be the first thing supported. That's probably true. Yeah. What's up, Rugman? How's it going? But yeah, no, I'm not necessarily switching from Pulumi to Terraform. I'm just using Pulumi for what I need. Okay, so interesting. So that kind of shows us, let me close this up. It kind of shows us from a theory perspective, I think what we can start with. So now I guess we want to talk about is creating reusable components for services that will be deployed in multiple places, right? And that's really what we're going to be working on right now. Now we could pick any service in particular. I think it makes most sense to pick the API, and this will be the Quirk API. And so this will be something that'll be related to Quirk, meaning that this particular component library or module library will be at least something that is a Quirk component library. But with the API, I think what we want to do is we want to take a look at it from the simplest level and then start building out and figuring out like what do we need. So we're going to start from the simplest resources, and then build out from there. And so these should be things like Kubernetes namespace, right? Deployment, etc., right? These are things that pretty much every one of these are going to have. The secrets and configs you build in the project did that module right? Yeah, so I did something kind of similar to that actually. If we go to GitHub, actually GitHub Alta 4, not dot files, but if we go to service Quirk here, and then we go to resource. Where is it? I think it's config maybe, or is it up here? Yeah, config.ts. This is a very simple, I mean super simple, two functions that I created that basically generate default values for things and standardize them. So the idea here is like API URL by default will try and get the override that I give it from Pulumi, right? And that's what this config get. But if that's not populated, which by default it would not be, then use a standardized URL that's like http://API stack or environment-API and then the port, right? So that's just something to kind of notice is like we will probably want to replicate this in some, like this is really what he was kind of talking about of like, standardizing even like the names of the secret. So for example, if we're grabbing a JWT private key, then it needs to be named, in Pulumi service JWT private key, right? So that they're all standardized and use the same. So yeah, some of this will probably be reused as well. Yeah. My bad. I had some questions earlier I missed, I think. Yeah, again, I'm just seeing this one more time. Bald Beard Builder, dude, thank you so much for the raid, man. I hope you're doing well, buddy. Arrive. Where was it? Do you write tests for modules? There it is. I remember. That's what I was looking for. So it just depends. It depends on like what kind of testing I need, or at least what kind of testing I'm trying to do. Like unit testing, I would say that's probably a good idea. Yeah. But I also don't normally do testing until I have a really good understanding of how to do proper testing. And I've not done testing for Pulumi yet, which is why I don't have any. So at some point I will have to actually add testing to all of this and make sure that it's, vetted. But at the moment I don't have any in this. Okay, so here's what we're gonna do, chat. Like I said, we're gonna take a look at the Quark API service, and we're gonna start from the simplest resources possible, and then build out from there. And that's gonna be like our Kubernetes namespace, our deployment, etc. So here's the fun part. I'm gonna let you guys pick. Well, I don't know if I'm gonna let you guys pick now that I think about it. Oh, this was the other article. Yeah. Oh yeah, I wanted to see this. So schema.json generated. Oh wait, so how exactly? Yeah, before I say anything, how exactly does create your own Pulumi package use this guide? A few key steps. Decide the type of package you want to create. Kubernetes, Azure native, Google native packages, bridge provider, existing resource provider from another supported ecosystem like Terraform, or bridge it, component provider. Oh, interesting. Write a Pulumi component in your language of choice and expose it to all users in all languages. Example, the EKS package. Interesting. So I think this is what we would want, a component package. We'd want to make a component package. Create the resource components you want to include the package. Either build a resource provider plugin, the binary that contains all the components or resources you define in your source code, generate the SDK for all. Holy smokes. Wait a minute. Wait, what? Do they have like a step-by-step on this? To create a Pulumi package, use this guide. Okay, here we go. Select a template. Go Python. Okay, so here we go. Go Python and TypeScript. Let's go look at the TypeScript one. Make file. Let's look at the make file really quickly. Go build provider SDK. Interesting. Build and test. Make install provider. Make generate. Pulumi XYZ. Pulumi stack init. Config. I'm slightly confused on like what that linking does, but okay. The repo is a boilerplate showing you how to create the component provider within TypeScript. So examples, simple, index, Pulumi static page, XYZ. So yeah, this is kind of what we want. SDK, .NET, Node.js, index.ts. But this was generated. Okay, I was like, I don't think those are things we're going to be making. Provider, command, resource. Oh, interesting. Index.ts. Main, schema, resolve, JSON schema, package.json, Pulumi provider, main, new provider, version, schema, args. Interesting. So this is if I want to make providers. So we have a decision we can make here, chat, which is decide on what kind of packaging we want to ship these modules in, right? And the options here are essentially language native, right? And that's going to be like npm, py, whatever, npm, and then whatever. So npm, etc. I don't know. I can't spell the other ones. I can't remember how to spell. And then this one is doing it as a provider, as a Pulumi provider. And so the idea here is like, if we go back to the example, you'll see that they import XYZ and then use like static page. They can create a whole static page from their module by just doing like XYZ static page and then getting that component and stuff out of it. So that's interesting. If we go into provider, what's also really interesting is like they've got like go here, and then we go into command. The resource itself, all of this stuff is in TypeScript. Huh. Main.go. What is this? Emit SDK.net. Interesting. So this will emit each SDK for each language here. Generate XYZ. Oh, I see. Okay. And then the resource is just TypeScript. Schema.json. Where's the schema.json? Oh, it's not in here. What? What? Require resolve schema.json. Package.json. I'm interested in knowing where that came from. NuGet. Yeah, thank you. Okay, so the TLDR on this is that this is something we can do. I'm just wondering if this is too much for what we need right now. And I don't know if this is something we really need to worry about too much because, yeah, here's the implementation of it. So the implementation is still a component resource at the end of the day, meaning that at the bare minimum, we can still write this automation and not necessarily make this decision just yet. Outside of, I guess, we just need to pick the language that we want to use. So we can either go with Go, Python, or TypeScript. Or at least these are the ones that they have boilerplates for. And this is if we wanted to make a provider. If we didn't want to make a provider, then we just make it a module and share it as a node module, right? If we decide to go the TypeScript route. Like I kind of want to use like Python or Go, but like, has anybody here used Pulumi with Go? I don't want to use Python because Python just doesn't have types, and I don't want to deal with Python types. I really want types. What would you rather write Pulumi in? Would you rather write Pulumi in Go, or would you rather write it in TypeScript, Orca? Yeah, I was worried you were going to say that. It's just really easy to write it in TypeScript. All right, let's do this. We'll do it only for the demo. Which should we use? Go, TypeScript. I'm going to give you guys 2 minutes. Which should we use? You pick. I don't really mind either way, I guess. Again, this will just be for, if anything, at the bare minimum, just writing for the demo. Dang. Neck and neck, though. TypeScript is just 2 votes behind. There you go. Now it's just 1 vote behind. I just did it to mess with you guys. Somebody else voted Go. You guys really want to see the Go one. We need to keep it 50-50, people. I mean, it's being kept pretty 50-50. Which is either just being done purposely, which in that case, then just guys. And then secondly, if it's really that close, that's funny. No, it's probably gonna be Go. It'll probably be Go. If that's the case, then let me go to development language Go source GitHub here. I don't mind Go. I think we'll be okay with Go. We'll see though. I might literally be regretting saying that. It looks like Go's gonna win unless we get a few TypeScripts. Anybody? TypeScripts? Really quickly? TypeScript? Anybody? All right, Go. All right, we'll do it in Go. Okay, so here's what our goal is going to be. Is we're going to decide on what kind of packaging, and we'll do this afterwards. So we're going to implement a simple Quirk service. We're not even going to, no way. We're going to implement a simple Quirk service. Yeah, implement a simple Quirk service. Start with the simplest resources, then build out. And then we'll decide later on that. We're going to use Golang to start, to evaluate the language with Pulumi. Use Go to start to evaluate the language Pulumi. If we don't like using Go, we will revert to using TypeScript, right? So that's another thing we can note is like, hey, if we don't like using Go, we're just going to revert to TypeScript. We don't have to fight about that, right? We don't have to like be like, oh, what do we do? Just go use TypeScript. Use what we like, and then we'll decide on the package later. So, all right, yeah. So let's do that. So we're gonna go ahead and start creating some stuff in Go. So we've got Pulumi installed. We've already got Go installed. So now we're gonna want to create a new project. So we're gonna say Pulumi new Kubernetes Go. And I'm creating this new directory right here in my Go path, right? So you'll notice it's like home, Eric Reiner, development language, Go, source, GitHub. If you've ever used Go before, you know what the Go path is. So I'm going to make dir, and we're going to call this, what should we call this? So I am probably going to rename my automation. Like right now, for example, we've got like Quirk worker email, which is for like sending out emails, right? And then like Quirk service API for like services and stuff. So I think we need like Quirk Pulumi, and then this will be like components, maybe. We'll just call it Pulumi components or something like that for now. And so we will go into here. It's an old thing, but it's something I do just to make sure that I have like reverse support and all that kind of stuff. And then we're going to copy and paste this into it. So like I said, I created a new directory called Quirk Pulumi components, right? And then inside of that, I'm going to run the Pulumi new Kubernetes Go command. And this should bootstrap me with with everything I need. So here we'll say Quirk Pulumi components. We'll hit enter. Hit enter. I'm actually kind of curious if this is what we want to do. Because the idea with this is that we don't want to actually like make stacks and stuff. So what we're doing right now with like initializing it and all of that is kind of not what we want. So let's Control C that really quickly and do the help. Okay, so let's see. Config dir force generate only. Do not create the stack and save config or install dependencies. Yeah. Let's do this. Let's do generate only. Like I said, we don't want to actually create the stack or anything. We're creating a library more than creating, anything else. So let's delete this, delete this, delete this. And let's try this one more time. And we will say Quirk shared cloud components. Oops. There we go. Okay. So to perform an initial deployment, run Pulumi stack init and then run Pulumi up. Now, remember, we're not going to worry about actually trying to deploy any of this or anything. We really want to use this more as like a module. So if we look here, we'll see we've got a go mod, a pulumi.go, and a pulumi.yaml file. If we go into the go mod, we will see that we have Pulumi Kubernetes as well as Pulumi SDK. So we have the ability to work with Kubernetes as well as work with Pulumi directly. Okay, so let's do this. Let's go to the main.go next. Now, if we look at this, this is our main entry point, or the code that's actually ran for our Pulumi automation. And so you'll see here that we have package main at the top. Then we have an import of a bunch of different stuff. We have a main function here where it says like Pulumi run. And then we've got string map, new deployment, all of that kind of stuff. And this is really just a very simple Kubernetes deployment. And you can see here deployment, apps v1, new deployment, all that kind of stuff. And then we just check to see if we've got an error. And then if we do, we return it. Otherwise, we return any exports we need as well. Yeah, that's pretty straightforward. Skip update check true. Yeah, I know. I just got to add it to my environment variables. Okay. And then finally, Pulumi.yaml. And this is the configuration for Pulumi itself, where it tells it what the name of it is, the runtime, the description, all of that kind of stuff. Cool. Okay. So I'm going to do go mod tidy first, just to make sure that we have everything downloaded and that the modules are up to date. We go here. We can see here's our sum, as well as our go mod itself. Have you looked at Kubernetes X, by the way? I have, but I've not really tried diving into it yet. That's just like another layer of abstraction I'm not ready to mess with yet. Okay, so here's what's interesting. First and foremost, is my... Oh, that is running. Okay, cool. Cool, that looks good. I just want to make sure, like, am I getting... Yeah, I am. Okay. So the first thing to kind of note here is like, we really don't need this function main. And as a matter of fact, we kind of want to turn this into a package library instead. I'm going to keep it as main right now, but this is really meant to be something that's more of a package. So actually, no, we can just change it. So we'll say quirk Pulumi components, except for you can't do that, so you gotta do that. Quirk Pulumi components, and so this will be the name of our library. Now that we've done that, we can actually get rid of all of that because we don't need any of it. And then it's gonna want us to get rid of all of this too, which is totally fine. We do that, and now we have a very simple main.go with just package Pulumi components. Okay, so let's talk about what we need. And to do that, we're going to go to our service quirk repository, and we're going to open up our API resource. Now, this here is what we're trying to figure out, like, okay, what do we need? What are the types of characteristics of our services, and what are the things that are kind of shared, for what we're trying to make. So what I think we need to do first is we need to create this component resource like we have in TypeScript in Go. And we need to be able to return that. Now, this is going to be in a type sense. So let's see how you do component resource Go Pulumi. So this is all in TypeScript. Come on, man. Oh, I just looked at that. Let's look at this. Go. Here we go. Okay, new resource. New resource. So it would be a new component resource then. So let's try this. Let's say we want to return it. Do we want to return it? Or we just want this to be a value? No, it's a function that's evaluated. Okay, so let's do this. Func new service, right? We're gonna go back over here. We're gonna do new service. And then what we want to do is return a new component resource. Now it's not seeing that anywhere because I don't have the Pulumi package imported. So let's go ahead and get that imported as well. So we'll go back here. We'll go import github.com/Pulumi/ is it just Pulumi? Wait, I have no idea what the original path was because I completely pruned it from this. So let's go back to is it still in my history? Might be. It is not. Is it not Pulumi? Is it? Okay. Maybe it is. Let's see if now we can use it. Could not import. Here we go. Pulumi dot, there we go. New resource component. Okay, so they don't seem to have new resource array. Interesting. So we're looking for new resource, right? All resources have the required name. Custom resource, component resource. Maybe we're looking for a component resource. Component resource, there we go. This is a variable though. Is it? It's an interface, but is a resource that aggregates one or more other child resources into higher level abstraction. This is not at all what I was expecting this to be. So that's fun. Oops. Let's go back to here really quickly. Also, I'm wondering if there's like a collision. Yeah, there we go. Okay. Resource. There's a resource that aggregates one or more child resources. Okay, so we should then be able to just, okay, so new resource. Pulumi new resource. That's still not what we're looking for. Pulumi.new resource array. API reference. I'm trying to create a component resource in Go. That's all I'm trying to do. Well, I'm on the component resource page. That's not a problem. What I'm looking for is what the import is for it. No, I'm not. No, what I'm saying is I know of the article. What I don't know of is how. Oh, okay, here we go. Maybe this is what we're looking for. Authoring a new component. Okay, cool. Never mind. This is what we're looking for. Type my component struct Pulumi resource state. Pulumi resource state. So it new my component register resource register component resource. Return my component. Okay. Creating child resources. My parent. Okay. All right. Yeah. Thank you. Okay. This is what I needed. Thank you. All right. So let's do this then. Let's bring this. Or I guess we don't really need to bring this over here. So type my component struct Pulumi resource state. So let's do that first. So we'll say type quirk service, I don't know, struct. And then we will add the Pulumi resource state to it. So Pulumi.resource state. Cool. And then we need to create a function that creates that resource state. So new my component. So this will be func new quirk service. And we don't have to do quirk service. We can just do new service. And we can rename this from quirk service to just service. We'll call it that for now. That import, yeah, that import is fun. It's probably because of their versioned API and stuff. Okay, so context, Pulumi context. So we're gonna first grab the context. And it's gonna be a pointer to our Pulumi.context, right? And then we need a name for our resource or our component. And then ops, which will be a spread of all of the resource options. Resource. My stupid thing is messing up. Resource option. And then we should return a pointer of my component or an error. So a pointer of service or an error. Right? Make sense? All right. So first things first, let's talk about the comparisons of the two here. Let's actually, hold on. Disregard my editor freaking out. Okay, so let's talk about the comparisons of the first two here. On the right, I've got TypeScript. On the left, I've got Go. The import part is pretty much the same, right? We're going to have a part at the top. The one on the right just has more imports. That's the biggest difference, right? We still are defining our component resource. However, we're doing it in a Go sense where we are generating a struct, whereas in TypeScript, we'd be creating a class or extending a class and creating a constructor. Here, we're going to be doing it all functionally, essentially, with our new service function. So this new service function is really the point of reference right here, where we've now created our type. We've extended it, right? We've got our Pulumi resource state, which is on our service struct. That's kind of the same extension or extending we've got over here, right? And now where we do essentially where we do two things here, we're doing them, or we do two things simultaneously here, we're doing them both here, where we create the struct and then we generate the function for it. So you can kind of configure this is the class and this is the constructor. Okay, so we've got our function, let's say return. And what we want to do now is we want to create our components memory assignment. So we're going to say component like such, and then we're going to generate a new service like that in our memory. So we're going to have that new reference. So there we go. So then we should be able to return it like that, and we should have nil as well. Okay. Is not in your Go module. Hold on one second. Let's see what else we've got here. Let's go mod stuff. Okay, that's all just Go mod stuff. So should be good then to go here. And cool, awesome. So now we have our component, which is really just returning a blank set of services. There's nothing in here. We could run this right now. I don't want to because it will, yeah, sure, why not? Pulumi init. I don't have a Kubernetes cluster though. Kind C. Wait, let's do this really quickly. Hold on one second. Okay, sorry about that. All right, so we're going to do this really quickly. I'm going to create a new Kubernetes cluster so that we can run commands against it. Try using SourceGraph for code search. I've heard good things about it. I planned at some point bringing it to Hippo and seeing if we could use it. Okay, cool. So we should have a Kubernetes cluster up. There we go. All right, cool. All right, so now that I've got that, let's go back to Quirk Pulumi, right? Components. Should be able to do Pulumi init now, I think, or Pulumi stack init. Is that what it is? Yeah, there we go. So what this is going to do is this is actually going to allow me to run, well, okay, never mind. No, let's not do that yet. I was going to try and see if I can run this automation, but we need to be really using this somewhere else for it to work. So for right now, let's just keep focus on porting the code. But at some point, we will have to, import this somewhere and try running it and using it, though we might not get to that today. Okay, so new service, component service. Okay, so once I look inside of this component resource here, we'll see that we've got like a super where we declare it, and then we go directly into making labels for our component resource or for our Kubernetes resources, right? App labels. So if we look here, we can see error context register component resource, and that's basically where that super stuff is. So let's do that next. So let's get the super line over here. And so for the Go part, we're going to do, or for the Go equivalent, we're going to do error context dot register component resource, right? That's what we want. And then we're going to do pkg index and service name, and then the component with options. So component and then ops, like that. And then we'll say if error is not equal to nil, thank you, tab 9. For now, we'll just panic. Again, this isn't something you normally want to do, but for now, we'll just panic. Or no, we can actually return. Sorry, we don't have to do that. Nil error. My bad. That's right. This is meant to return errors. Okay, cool. So that looks good. So now we have created the memory allocation for our component, and we've also registered it with Pulumi as a service. But we still don't have anything really, there outside of just the shell here, right? And so just like how we use the super to register it here with its name and all that stuff, we're doing the exact same thing here in Go. So the next thing, logically, would be to start figuring out like how we're going to do labeling and namespaces and stuff like that. So let's do that now. So one of the things that's really nice about this library is that it's meant to be something that, standardizes things and makes them very reusable, meaning that we can not only start making, opinions about the whole service itself and the resources inside of it, but even the configurations for those resources. For example, if you've ever used Kubernetes, you've probably managed labels before, right? Like deployment labels and stuff. We can standardize that, right? We can standardize an interface that we say like, okay, if you use this interface, then you can create, labels effectively within our infrastructure. And so to do something like that, I could just be like type labels, right? Struct, for example. And then what we could do is we could say like the app label, right, would be like a string, right? That's a label that we could use. And so that translates to really what we've got here on the right, which is like labels equals app and then stack API. We can now create a struct for that that we can reuse. And so, for example, now what I could do is I could say labels, right? Labels, create a label struct, and then in here, under app, we say the app is the name of the service that we're trying to make, right? So now what have we just done in that simple opinionation right there? Well, we just made it so that everything that uses the label's value or variable, right, will have the app injected into it of the app that we're trying to deploy. So we just standardized labeling. Like, it was that simple, right? Bam. Now, if we want to add other labels in the future, for example, say like org, right? Then we do that, and then we come back down here and we say org, right? And then maybe this is like alt F4 LLC, right? That would mean that in the future, we could deploy services under different organizations if we wanted to, say, you know, a different company if we were building something for somebody else. But for now, this is entirely fine. So let's keep moving. So we've recreated our labels, right? Let's now recreate an actual Pulumi resource, which is our cloud namespace, or I'm sorry, our Kubernetes namespace. So we're going to actually have to use the APIs again for this to make this work. And we're going to need to note about how we create child resources. So if we look here, it says like s3.new bucket and then context and name. And then we'll see at the very, very end, Pulumi parent my component. And this is what we need to kind of pay attention to, which is how do we, even though these resources are in, and this is something to like note here, even though these resources are in this component and we've registered it and everything, functionally, we've not given any reference to how any other cloud resources made relate to each other, right? So effectively, if I just started making cloud resources right now, the only thing that would happen is they would provision inside of the component that we are creating, right? But they would not have any of like the dependency trees or anything like that. They would just get provisioned on the fly. So we have to make sure that we tell it what the parent is, even though it's in the function, because at the end of the day, this is still just a function. We have to lean on the, you know, logic of Pulumi into telling it how all of these things interact with each other and inherit from each other and things like that. So there's two questions we need to ask here. The first one is to do, right? How do we create a namespace, right? A K8 namespace. And then to do, how do we assign that resource to the component, right? So let's go ahead and start on the first one first, which is how do we create a Kubernetes namespace? So if we go to the Kubernetes provider, Kubernetes provider, Pulumi Kubernetes provider. We should be able to see the API in different languages. Yeah, here we go, right here. Bam. All right, so we've got our provider. We need to find a namespace. Here we go, namespace. Boom, here's our Go example right here, new namespace. So we need context, name, args, ops, and then we return a namespace or an error. So let's do that. So we're gonna say namespace, error, new namespace. Okay, so we need our Pulumi package. Pulumi, oh, no, we need Kubernetes. Kubernetes, there we go. Kubernetes dot core, is it v, where is it? You're going to make, wait, core v1. So Kubernetes core v1 names. Huh. How doth I get to... Oh, thanks, Nanobots. I appreciate that. Yes, I have no alliances to editors. No IntelliJ. I have actually got, believe it or not, chat, I have the JetBrains like full licenses. And I've thought about like stepping into using one of these for a little while just to see like what I think. I needed data grip. I'm literally paying $20 something a month just for data grip. Because when you look at the licensing, you're literally jipping yourself. Well, that's not a good word. You're literally what's it called? Shorting yourself by buying just the one license. Because when you look at it in comparison to how much it is for everything, which is like $30 a month, and you get all of their other tools, it's just like, yeah. Now, here's the thing. You're not wrong. They're definitely grabbing our money. It is what it is. But I love DataGrip, man. I think DataGrip's a great product. I have a lot of friends who use DataGrip too. So. Okay, cool. So new namespace. So why are you not giving me the right provider? Set the Kubernetes. No, see, that's not it either. So I'm wondering if it's like a core thing. Maybe V1. There's something. Look at that. Name. Oh, but see, that's not. Oh, but that's certificates. So where is it? Kubernetes dot package version uses the reflection to determine the version of the current package. What? Yeah, no, it's not that expensive. I think there's a discount also. Yes, there is. Yeah, JetBrains does do a good job of really trying to help people out, I think, in the sense that like they have some pretty cool deals and stuff for like they actually have a streamer deal. I forget what it is, but like they're like, if you're a content creator, we'll give you things. I don't remember exactly what it is. So here's the thing, chat. I can't target, or I'm not getting output for V1. So if I do V1 Kubernetes meta RBAC coordination meta, I mean, it's got to be this one, right? No, those are API extensions. Where's the actual Kubernetes like thing itself? Where's that package? Package details. Oh, here we go. Pulumi Kubernetes. Oh, it's in Pulumi-Kubernetes. So Pulumi Kubernetes. All right, let's try this. Pulumi Kubernetes v3 Go. Helm provider input. New provider. Do you need to like initiate a provider or something? Like namespace. I know this isn't what we want, but no, that's not what we want. Where are these resources? Yeah, I mean, getting your company to pay for it too also is a good play. New namespace. Let's try this really quickly. Oops. New namespace. No, but it's not seeing that. New service, but it is seeing that. Kubernetes. I mean, it seems like that is the right import. Pulumi Kubernetes SDK v3 Go Kubernetes. But then when I try and do like, is there like new, yeah, see, I can't do new namespace. version, package version, V1. Yeah, see, I'm not able to target the version or anything. So this, I don't know what this is, but this is not what I'm looking for. At what point do we start blaming Go? None. I need to see better examples. I don't like the fact that they're not showing the paths as well. That's the problem, is like they're just showing the function. They're not saying like kind of the important part, which is like where this comes from. They're just showing you like, you know, the small logical component of it. This is all TypeScript though. Deploying a Helm chart. All examples. I thought I was just looking at Go. Yeah, Go Kubernetes. README. Why, when I go to the... Oh, it redirected me. Oh, I see. SDK, Go Kubernetes. Oh, what? There's no longer a... What are they doing with all of their documentation? Run stateless using deployment, rollout. All I need to do is know where this new namespace thing is. Kubernetes core V1. Oh, maybe we're looking for core? Core V1. Okay, I have no idea where this is. Component resource state. Go to the API reference. Well, I mean, that's what we're looking at right now. Core. Okay, let's do this. Let's go here. And we're grabbing it from where again? Pulumi Kubernetes SDK v3 Go Kubernetes. So Pulumi Kubernetes SDK, what is it? v3. Wait, where is that? I don't see v3 anywhere in this folder. I see Go Kubernetes. That's interesting. Oops. Kubernetes v3 Go. Pulumi packages. Oh wait, no, that's not what I want. Nope, that's not what I want either. Here we go. Yeah, no, this definitely isn't a Go thing. Pulumi communicates with the API using the Go Kubernetes just like kubectl does. Okay. So here's what I'm trying to figure out is this maybe out of date? Oh, to use Go, grab the latest version of the library, SDK. Where is this path though? Like, I don't see this. Yeah. Yeah, this doesn't work. It's 404ing. So how is this possible? This must be out of date for the Go stuff. Which makes me think that the API's docs are also potentially out of date, maybe. Can you try to go get it? I already have it. I mean, I have something. I have something that is Kubernetes. Deploy apps with Kubernetes and Go. So kind of, in the sense of like, okay, hold on. I'm going to try something really quickly. I did this not realizing that this was going to be this big of a deal. Make dir temp template new Kubernetes generate only. Yeah. There we go. Okay. Okay, here we go. Oh, these imports are weird, dude. That's why these aren't working, because I have to do this like this. Okay. All right. This is what we need, chat. That's literally what we need. All right. So let's go back here. Main. Yeah, we need those imports. We can't use like the normal whatever. Okay, so then now what I should be able to do is do core v1 dot name new namespace. Bam, there we go. New namespace. Yay, we found it. It just took forever. Okay, so new namespace. The namespace takes what? Context, name, and arg. So context, name, we can do labels.app because we want the name of the namespace to be the same as the service name. At least for now. Oh, where'd I go? And then we can go back here now, actually, to where it was before. Components. API reference. Kubernetes. Honestly, nanobots underneath the hood, VS Code uses the same thing as I do, which is the language server. If it had extra things, then maybe that's fair. But 9 times out of 10, most of the things that I get, you would get in VS Code. Okay, so we've got name, string, args, and ops. Now remember, we talked about... Oh, did I just accidentally close the wrong one that I meant to close? Nope. We need to also give it the parent. Here we go. This is what I was looking for. All right, so we also need to give it the parent, which is this part right here. So context, the name, args, and then the parent after that. So pulumi.parent my component. Okay, so we're gonna give it just a simple args. So args core v1 namespace args. So we'll say namespace args. Core v1 namespace args. Core v1 namespace args. Create that. I think this might need to be a reference. Yeah, it does have to be. So we'll make a pointer to it. And then in here, we've got API version, kind, metadata, and spec. So if we go to metadata, right, we should then be assigning or able to assign meta v1 object meta ptr input. So meta v1 object meta ptr input, right? That's what we said it was. Yep, looks good to me. Okay, so now we should have the ability of giving it a name, I believe. Name to service. Meta v1 object ptr input. Okay. So let's do this. Pulumi output state. Interesting. My assumption here would be in the same way. So if you see here on the right, we do like namespace, labels app as the name of the actual resource. And that's this labels app over here, right? But then after that, we do go into the metadata and actually set the name of it as if we were setting it in Kubernetes directly. So that's kind of just what I'm trying to understand, how we declare that. Return nil error apps. We don't need that for right now, but I'll need it later. Actually, here, we'll just comment that out since I'll need it later. Okay, and so this is namespace declared but not used. Yeah, except for I really want to be able to add metadata here. So I should be able to do like name to service spec, but I don't know what any of these are. String. Oh, wait, can I just give it labels.app? Is that okay? Oh, missing comma. Unknown field instruct literal. How about now? That's still, yeah. So it doesn't know. That doesn't make sense though. How does it not know? Like, how do you do metadata naming conventions? I guess is my question. Let's go back to our example. Great. It says nothing about metadata in here. It says spec, core v1 pod spec args, template args. So maybe what this needs to be is a args of some type. I think that's what we're looking for, chat. So, oh, it is names. Well, oh no, but this I think needs to be object meta args. Yeah, I think this is what we're looking for. And then I should be able, yep, name labels.app. Cannot use labels app. Is it a string Pulumi PTR string or PTR input? Oh god. I was meaning to ask earlier, what exactly do you think of Golang in the DevOps world? I think it's great. Yeah, I think it's great. Shouldn't you use a PTR input? Yeah, so I think I have to, right? But yeah, I think Go was kind of built for DevOps in a lot of ways. Yeah, I think I have to, but I think I need a function that allows me to turn this string PTR string PTR output. I think there's a way that you can like returns a pointer to its argument. Oh, here we go. String PTR. There we go. Yeah, it's this. So then I should be able to do labels.app. Bam. There we go, chat. Not too terrible. I mean, you know, it's definitely a little confusing, right? In the sense of like, this would not be this difficult with TypeScript. Can we all agree with that? This is definitely, you know, a bit more verbose. Granted, you know, we were able to achieve, we've got 47 lines here, and TypeScript, we probably were able to achieve it in like 20, 25. So it's definitely a lot less, to say the least. Pulumi.parent, right? And now we're going to assign the parent, and we're going to do that by saying that it's the component that we have given it. And that should be it, chat. We now have a namespace here that we have created, core 1 namespace. And so if I do like namespace dot metadata dot name, there we go. Now I have the name of the namespace that I can use in different definitions. But let's talk about this here a bit, right? Like, let's talk about this a bit. So what have we made so far? So we talked about using component libraries, right? We've gotten to the point now in our infrastructure and our automation where we've come to the point where we need to have resources that we can deploy in multiple locations that keep the same configurations or similar configurations, right? So for example, if I want to redeploy the API service to Quirk in multiple environments or in multiple automation stacks, then I need a way of sharing these resources and having that standardization so that instead of me having to rebuild this whole component resource like I'm doing right now, right, from like Go to, you know, whatever, that I can do that with, you know, I can do that with Go as well. And so, you know, we took a look at this, we broke it down into what we were missing. We tried porting it over to a Go library, which is what we're doing now, and, you know, kind of seeing the differences. Now, the thing is, with this approach, I can't use this. So let's talk a bit about what we've discovered so far, which is if we go with a language native, right? Have a good one, Nano. If we go with the language native, then we can only use these modules in the language they are built in, right? This is a limitation, so we'll say limitation, right? We don't have to do that. We can say we are limited to using these modules in the language that they are built in, right? So that is one thing to note. Is I don't want to go too far with this, because if I decide to go this route, the just language native npm, you know, whatever, then I'm not going to be making these in Go. I'm going to be remaking all of these in, like, you know, classes and stuff. Really what we've got here. Now, the thing to note about this, right, is we're looking at this and we're saying, like, okay, what are the things that every service has, right? Every service has a config map. Every service has a secret. Every service has its own isolated namespace and its own, you know, deployment and all of that kind of stuff. And we're taking the stuff that everything, or that every service has, and we're adding it to this library so that everything that they don't have, we can make configurable and things like that. But like I said, if we decide to go down the language native approach, I really shouldn't be building any more of this in Go, because I'm just going to be rebuilding it all in TypeScript. If we go the Pulumi provider approach, this is new territory and requires more investigation. And requires more investigation, really. And that's really this one right here, the Pulumi packages. And so the whole idea here is that you're really just creating like a Pulumi provider that you can compile down that they can then use with the Pulumi application itself. This is new territory, requires more investigation, possibly also requires its own automation and pipelines. And so that's another thing to note, is like, if we go this Pulumi provider approach, the way that I looked at it, it looks like this is something that's more of like a make file where it gets like compiled down and then that's used with Pulumi. So this is something we will investigate in another stream. I'm not doing this today because I've got like a bunch of stuff going on. But I want to share this with you guys now, as this is something that we will be looking at. But at the bare minimum, if we use the language native one, since these are in the same language, it's very easy to get up and running, right? And this is with like packages, imports, etc., right? Like it's all just, it's very easy. We don't have to worry about that. However, with the Pulumi provider, again, this is new territory. We don't know exactly how we import them after they're built. Where do we store Pulumi packages, right? Pulumi packages. Where do we store Pulumi packages? Do they still get pushed to a language repository like npm, etc., right? Like, and that is something to ask, which is the whole point of using Pulumi packages is to make it so that they get compiled down to multiple languages and then those get shipped. But if at the end of the day, our Pulumi packages are just going to be in one language to then be compiled to another language, there's a lot of argument, and I totally understand it, of people being like, hey, don't use the same thing for everything. And I'm one of those people, actually. I absolutely don't think you should do that. However, when we look at the scenario here, like look at this scenario, chat, right? We can keep everything in the same language, right? And have really easy reusability, very well type defined schemas and type definitions. You know, we can keep it, and I'm not even saying like it's Go or TypeScript or anything like that. I'm just saying that if we choose to not take the Pulumi packages approach and just go language native, we are limited in the sense that we can't use other languages. Yes, that is true, because we're just building a language or a library for one language. However, because it's in the same language, we don't have to worry about managing potentially multiple packages, right? With Pulumi packages, these might get distributed and created to like what if we don't, like, if we're not even building automation in Go, why should we build a Go client? Right? Like that just, there's no point to that. Now, again, that could be something we could use later on. It could be something really cool to where, you know, we want to be able to, you know, start making other packages. So I'm not necessarily saying that it's a bad thing. I'm just simply saying, like, is this something we need right now? And this would be like Go, Python, Node, right? Registries. So, you know, these are kind of the pros and cons of what we've learned with what we just did. I think I'm at a point right now where I need to take a step back and investigate Pulumi packages more. So I think we're going to go ahead and pause. I think I'm going to go ahead and stop here. I think now's a perfect time because I've been going for almost 4 hours anyways. So yeah, again, chat, what I want to note is that, you know, today we went through a lot. In our today's agenda, we started by talking about how we restructured Alta 4, how we, you know, wanted to have more of a purpose for our solutions and build more reliable systems. So we refactored our network and our automation and all of this other stuff. And when we did our automation refactor, then we talked a lot a bit about, you know, like, where does the automation go and what kind of concerns does it have, and the repositories that we create for those and all of that stuff. And then we finally got to where, you know, we decided we want to be able to create reusable components for services as well. You know, we want to implement a simple quick service, or we want to implement a simple quirk service. Start from the simplest, you know, build out kind of what we just kind of talked about. Again, every service needs namespaces, every service needs configuration, stuff like that. And, you know, really where we're leaving off now, which is, all right, we know that we want to, you know, we know that we've rebuilt our virtualization automation and we've restructured it and, you know, done all of that other stuff. Now we, and actually I should add one other thing to this really quickly, which is we rebuilt our, container automation with Pulumi to integrate with Kubernetes, right? And then we also, again, created reusable components and all that kind of stuff. So yeah, you know, there's a lot in here. I'm going to investigate Pulumi packages to give you guys the link. I'll make sure that the link is in the document here. But remember, you guys don't have to miss anything ever again when it comes to the stream. I am now managing all of these documents in our Alta 4 wiki. So if you ever want to reference the VOD, two things. If you ever want to reference the VOD, you can do that by going to Twitch streams. I'm about to answer your question, Otzi. And in this section of the wiki, Twitch streams are every single one of our daily agendas. Now, there's two parts to this because I'm trying to cultivate a fun experience for you guys here. When you look at one of these, you're not going to get the whole breakdown in a sense of like, oh, hey, like I can either read this or watch this. There are things that are meant to be a guide. Like if you click, you know, 30 minutes into the 45 minutes into the video, I should be talking about this kind of stuff, right? Now, Twitch only lets us have our VODs for 60 to 90 days or something like that. Sorry. And so what we have done now, finally, after I got it all up and running, we have created a new YouTube. So we have 2 YouTubes, chat. We have two YouTubes, and I'm going to go ahead and update our quirk command for it. So we have our main YouTube, which is the Alt F4 stream, and that's where like all of our educational content, all of that stuff is going. But now we also have the Alt F4 archives. And in the Alt F4 archives, that is where you can find all of our previous VODs. It's available. Please say 2 YouTubes. 2 times. 2 YouTubes. 2 YouTubes. 2 YouTubes. But yeah, you can check out our Alt F4 archives, which are right there. And the Alt F4 archives are where all of our VODs are going to go. Now, to start 24 hours in advance, just so you guys know, we have to use Twitch. We have a contract with Twitch that basically states, as a partner, we can't publish our VODs to any other platform for 24 hours until after that. So we have to wait. But we will post the Twitch VOD, and then once the YouTube VOD is updated, it will be replaced in here. But no matter what, this is where you can go to find all of the latest updates. So I'm going to do this right now. I'm going to create a new topic. I'm going to say 02/16. That's today's day, right? 16/2022. And then we will say, what was it? What did I go live with today? I forget. Oh, wait, what's in the today? It's in the today. Yeah, here we go. Infrastructure as code, libraries, resource libraries. Yeah, that's basically what we worked on. And so now what I'm going to do is I'm going to grab all of this. Now, this is the only document we created today, so there's no other links to any other documents. But if I had links to any other documents, I would give them to you. Now, there is actually one other thing that's pretty cool that we can do too, which is we can go to Twitch, go to our channel. I'm literally giving you guys the stuff that you can leave with. And so here we go here. We go, you see this right here, DevOps work? This is the actual VOD from today. Kind of neat about Twitch is it allows you to grab the VOD as it's being generated. So I'm going to go to share, embed. We're going to grab the embed here. I'm going to close this out. We're going to go back to here. And then we're going to go at the very top and we're going to paste in that embed. Just like that. Boop. And we're going to change this to Alt F4 Wiki. And boom. Going on. There we go. Oh, geez. Okay, cool. So there you go, guys. You guys can now get the VOD as well as all of the topic and everything. It's all on the wiki. Oh, please tell me I saved this in the right spot. I think I did. All right, chat. Yep, we did. It's in the right spot. It's in the Twitch streams. Cool. Okay, chat. So check it out. If you guys want to check out anything that happened today, there it is. There's your link. Be sure to check out the wiki. It's a pretty extensive one. We talked about a lot today, and I talked a lot in, I would say, the first like hour and a half of just like practice, why we did what we've done, like all these other kind of things, as well as, yes, check out the YouTubes, both of them. The first one is where we're posting all of our like educational content and stuff like that. The second one is where we are posting all of our VODs and stuff. So any VOD that's embedded in the wiki will be on that YouTube. So yeah, be sure to check out the wiki. There's a bunch of other really cool stuff in there. I've been including my own technical documents that I work on, whether they're on stream or off stream. If you're ever curious about how we're solving problems like our low latency, high quality live streaming audio setup, how we structure our Pulumi project repositories, how we do discourse distributed deployments, hybrid environments, converting OBS recordings in MKV. This is actually a new one, by the way, this one here. This one is this is something we're going to be doing in the future, but we had to solve for the problem of us storing OBS recorded videos in the MKV format to prevent losing live content when an issue occurs. However, we are unable to do anything with this format and need a way to convert it to MP4. Well, guess what, chat? Because we got the power of the Kubernetes as well as virtual machines and all of this other really cool cloud infrastructure and architecture, we will be creating an OBS recording pipeline. And I've actually put the document in here already for you guys if you want to take a look at it. But the main point of this, just for spoilers, is we want to be able to stream directly over to our Samba network share, right? Have the audio or the footage go directly onto the network, and then have a cron Kubernetes job that uses NFS and Kubernetes to mount that same share, convert it, and then send it off to the cloud so that we can use it later. So this is something else that we're going to be doing. We're going to be building. This is something that I'm sharing with you guys. Like, we're not hiding anything. You guys can have all of this cool, awesome information at your fingertips. The last thing to note about the wiki is you can be a part of the wiki. It is something that you can sign up with via GitHub, contribute, add your own articles, things like that. We've got a bunch of other categories that I'll be adding soon, as well as, you know, other sections and stuff like that. So if you ever want to add a technical document or talk about, you know, how to build a home lab or, you know, talk about software and development, stuff like that, feel free to, you know, join the wiki. Okay, so now that you know about the wiki and you know about the YouTubes, remember, the first YouTube channel is our main YouTube channel where all of our educational content and stuff is going to go. The second one is for our VODs if you ever want to see, or really just clips in general. Anything from Twitch that we have accumulated that we want to keep will be on the Alta 4 archives. Outside of that, again, if you're new to the channel, be sure to check out this little blurb right here. We are a variety channel by myself, as well as my good friend Atoda. He plays video games and does IRL content. I play really a lot of programming and video games sometimes. But we also do streams together where we'll play video games together, do stuff with the community, things like that. So you will see somebody else on stream. It is not just me. We are quite a unique experience over here. Outside of that, we do have a bunch of wonderful people in our Discord. If you ever do the Discord thing, you want to be a part of a pretty awesome community, you have questions, anything like that, you're welcome to be more a part of the real-time conversation in our Discord. What's neat, and I want to put this out there for you guys as well, is we have really long ongoing conversations in our Discord that, you know, can span like days sometimes. And threads are really nice, but I'm trying to get that stuff moved to the wiki so that these conversations can grow even more and further. So the wiki and the Discord really are meant to work hand in hand and kind of complement each other in that way. So that's something just to note. Outside of that, we also send out all of our go live notifications, all of our other notifications, whatever. If you ever want to know anything we're doing, be sure to check out the Discord. And then finally, chat, we also have our social medias. So if you ever want to, again, there's our first YouTube channel. But if you ever want to like be a part of, I don't know, any weird stuff I'm talking about on Twitter, or, you know, stuff I'm seeing or whatever, you're welcome to follow our Twitter as well. I try and stay pretty active on that too. So yeah, thank you guys so much for hanging out with me today. I really, really appreciate it. Let's go find somebody to raid. You beautiful, beautiful souls. Let's see if we can find somebody to send you guys off to. Thank you guys again, though. I will be back Friday. I normally stream. If you don't know my schedule, it is Monday, Wednesdays, and Fridays. I normally start around 11 a.m. Pacific Standard Time. I normally go between 3 and 4 o'clock-ish, something around that. And that's normally Monday, Wednesdays, and Fridays. Sometimes I do have to stream Thursdays, though. That is also Atoda's stream day. So if you guys didn't know, if you ever want to check out his stream, what he's got going on, again, he does a bunch of different cool stuff too, whether it be building Gundams or playing the newest release of a video game. Yeah, be sure to check out his awesome show on our channel too. All right, so let me see here. Who do we got? Well, it's been a long time since we rated this person. Oh, they haven't even started yet, though. Hold on. Is there anybody else doing DevOps, man? Can I just get like one other engineer I was literally, dude, Digital Fortress. I was just about to say we haven't rated Splashly in a long time. We'll give her a second. I don't know how long she's gonna take to go live though, so that's kind of the challenge. She's still starting. But seriously, could I get like one more DevOps engineer on Twitch, please? Like, Mastermind was around for a while, dude, and like, what happened, man? Like, why doesn't anybody like do what I do? I never see another DevOps engineer. I'm like the only one. I never see DevOps deploy it. Like, you know, like, I don't know. Morgan Short is my first job. You're a light in the dark. Thanks. Yeah, Mastermind is awesome. If you guys don't know Mastermind, he is a very, very knowledgeable guy. Very knowledgeable guy. And just honestly, very sweet guy too. He's super down to help and educate and grow and, like, you know, take you to the next level. So I just show you guys what I do and hope that, you know, some of it sticks. That's really all I do. I'm not so much of a teacher. It's just like, you know, see if you like this. Should we just go raid Splashly? We could force her out of her starting soon. You guys want to do that? All right, let's do that. We're gonna, I don't want to guarantee you because she might not be paying attention, but we're gonna go raid Splashly. She's in a starting soon right now. Normally, sometimes when people see, like, even when I'm starting soon, I'm watching the stream every now and then, you know, like to pay attention of like what's going on. Let's see if she's watching her stream or if she's actually really gone from it. So let's go raid Splashly. Thank you guys again so much for hanging out with me today. I will be back, like I said, Friday. But tomorrow, tomorrow, Atoda will be streaming. Be sure to check out that stream. And if not, I will see you guys. I will see you soon. Remember, check out the Discord, social media, all that stuff. YouTube, blah, blah, blah. YouTube, blah, blah. Okay, all right, guys. Love you. Enjoy the rest of your evening. Enjoy the Splashly content. See you soon. Bye.